Hello everyone, this is Pranav from DFI of India office. I welcome you all to this workshop on continuous flight auger, that is CFA piles theory, prospects and applications in India. This workshop is jointly organized by DFI of India and Indian Geotechnical Society, Kolkata chapter. Few quick instructions before we start the program. Recording of this webinar is prohibited. Participation certificate will be emailed in approximately 2 weeks. And also the online webinar recording will be available on DFI of India YouTube channel in approximately 2 weeks time. For the audience, this is your Q&A tab. You can find it in the in your Zoom menu panel. You can click on the Q&A tab and enter your questions anytime during the presentation to ask your questions to the presenter. It will be taken during the Q&A session after each presentation. Now, without any further delay, I invite Mr. Chiranjeev Sarkar, who is a principal engineer in GeoConsult India Private Limited, to formally welcome the audience and give an introduction to the workshop. Chiranjeev sir, welcome.
Yeah, thank you, Pranav. Good morning, everyone. On behalf of DFI and IGS Kolkata chapter, we welcome all of you to our online webinar and workshop on CFA files. There is a great scope for civil engineering and construction industry with the ever-increasing investment in Indian infrastructure projects. The global experience suggests that the construction projects that do not complete the foundation on schedule end up in major cost escalation and time delays. A speedy and safe foundation construction need advanced technologies and modern equipment other than those being practiced now or used in our country, India. So, continuous flight auger pile CFA pile technology is one of the such foundation system that has a great potential to improve the speed of foundation construction in India. We believe that this workshop is part of dissemination effort and will help in understanding how CFA pile technology can be a game changer in Indian piling industry and how it can be implemented in India. Regarding the workshop participation, we are happy to inform you that we have more than 380 registration from 11 countries. Among them, around 20% from student community, 24% from contractor side, 30% from consultant side, and 16% from educator, then 6% from developer, then 3% from supplier. So with this, I will again welcome all of you to our online workshop. Now I will hand over to Mr. Pranav to continue.
Thank you so much, Chiranjeev sir, for giving the welcome address to the audience. Now can I please request Dr. Abhijit Saha sir, who is Vice Chairman of IGS Kolkata chapter, to give a brief presentation of IGS Kolkata chapter and its activities. Abhijit sir, please.
Thank you, Pranav. Good morning, everyone. The Kolkata chapter of Indian Geotechnical Society, the innate story, it's the account of gradual expanse of a circle of geotechnical enthusiasts in Calcutta since 1964. It's the genesis of Geotechnical Study Circle Kolkata to Kolkata chapter of Geotechnical Society. The Geotechnical Study Circle Kolkata was born nearly 60 years ago. It started its journey in 1964 when the profession of geotechnical engineering was in its infancy in our country. A few passionate civil engineers involved in the field and research in soil mechanics and foundation engineering dedicated themselves to the cause of geotechnical investigation and cultivation of knowledge in the subject. In the early 60s, when soil investigation work was slowly taking shape, the Calcutta cell of CBRI and Cementation Company Limited carried out pioneering work in soil mechanics. Their efforts revealed the potential of such work in this part of the country and most geotechnical investigation methods used today in India date back to those days. Soil mechanics or foundation engineering and later geotechnical engineering is a relatively future entry into the study syllabus for civil engineers. Till 1960, there were no paper covering the subject in civil engineering courses. Even in age-old Bengal Engineering College, Shibpur, which was established in 1856 and presently known as IIEST, it was being taught as an extracurricular subject by Mr. Amitabh Ghosh Dostidar, a renowned geotechnical consultant of his times. After a few years, he left the academics and joined Cementation Limited Kolkata office as the branch head and became the most enthusiastic exponent of everything related to the subject. Those days, the most important geotechnical issues confronting the engineering fraternity in Calcutta were choice of type of pile foundation and safe depth of piles. Today we'll be talking at length on this subject, deciding on the bearing capacity of low depth footings and really design of the shoring that was required to buttress the sites of a deep excavation. Piling in those days was restricted to a maximum of 550 millimeter, 22 inches diameter, driven in situ RC or auger board piles that included underrim piles developed and promoted by CBRI Roorkee. Matters changed with the development of present-day Salt Lake area, created by filling up age-old marshy lands with silt pumped in from river Hooghly through steel pipelines laid for the purpose. The government-appointed body, Ivan Miltuvonik from Europe, carried out Dutch cone penetrometer tests that showed very high resistance in the pumped silt layer, extending to a depth of about 2 meters, and then almost zero resistance in the underlying soft clay and pit layer. The official interpretation was that foundation left in the silt layer will have high bearing capacity, and foundations left there will carry weights of the buildings easily, without anyone bothering about the rapid consolidation that would occur under the loads of 3 or 4 stories building that are placed there. A cooperative society purchased a large plot from the Salt Lake authorities as pioneers in 1967 to construct 200 apartments in 4-story buildings and received the soil report for study only after the transaction was completed. Confronted with this apparently insoluble problem, the engineers concerned made a collective study under the guidance of Mr. Dostidar, and it was decided to pre-consolidate the building footprint by putting loads manually on the area to accelerate the settlement. Sandwicks, a new modified form of sand drains then, with jute casing was invented and eventually patented by cementation. The buildings were first 4-story buildings in the township, eventually safely completed without piling at a much lower cost, and the engineering fraternity was highly impressed with the novel solution that could ensure completion of a project doomed to early demise. The importance of soil mechanics and foundation engineering was understood, and the group of engineers that participated in this new development decided to form a group for studying challenging foundation problems collectively and coined the name Geotechnical Study Circle. The first seminar by this group was organized at the West Bengal State Center of Institution of Engineers at Gokhel Road, Calcutta, and the attendees showed tremendous enthusiasm at this exposition of technical skill in a relatively new area of engineering. The engineers of yesteryear that were intimately involved in the study circle were Mr. Amitabh Ghosh Dostidar and Mr. Sudhin Gupta of Cementation, Mr. Amitabh Ghoshal of Stoop Consultants, Mr. D.P. Sengupta, the Calcutta representative of CBRI, Mr. S.P. Banerjee, a renowned structural consultant, Mr. M.N. Shah, Chief Design Engineer of Calcutta Port Trust, Mr. P.K. Banerjee, Chief Engineer of Southeastern Railway, Mr. Sholil Rai of M.N. Dostur, Mr. J.N. Rai, Chief Administrative Officer of Calcutta Metro, and a few others. The activities were limited to a meeting every month at different offices, mainly in the Eastern Railway, Calcutta Port Trust, cementation offices, etc., to discuss interesting engineering problems by a single speaker or a group of speakers with a PDF scope where available or simply with hand-drawn sheets. Topics were mostly related to foundation engineering, but sometimes of general engineering interest, like the high-profile restoration of Harding Bridge in Bangladesh. With the beginning of metro construction in Calcutta in 1979, soil engineering really found its foothold in the region. The cut and cover technique and the tunneling work of the first metro construction of the country necessitated application of advanced geotechnical engineering. It was perhaps natural that the study circle began to operate from Metro Railway Office, Calcutta. This generated widespread enthusiasm and interest in geotechnical engineering, and in no time it became a major local center of the Indian Geotechnical Society. Calcutta Metro incidentally did not have a consultant, and the study circle became its unofficial and unpaid consultants for all matters related to the underground metro construction. The first such project in the country, constructed along the most congested alignment and in treacherous sand and silt layers. Study circle had a permanent meeting place in Metro office for a long time and started organizing seminars, initially at 4-year intervals and then annually. Indian Geotechnical Society members, still in their initial years, started joining the seminars at Calcutta, mainly through the initiative of Professor Dr. Nitin Som, Jadavpur University, Kolkata, who remained a part and parcel of the organizing committee. In one such seminar attended by Mr. Dinesh Mohan, Mr. Professor Shoshi Gulati, and Professor R.K. Bhandari and others, the decision was made that the study circle will be a part of the IGS and become its Calcutta chapter. Well, this is what we have. I am associated with this organization for almost 37 years, but this we came to know from a very senior member of ours. He is most probably within us joined us in the meeting, Mr. Amitabh Ghoshal of Stoop Consultants. And the rest is recorded history. Today, Kolkata chapter organizes lectures by experts from Calcutta and other parts of the country and abroad at regular intervals. Group discussions, site visits, seminars, and workshops are organized. The study circle organized All India Symposia on application of soil mechanics and foundation engineering in 1968, 1972, and 1976. Thereafter, it started operating in a wider canvas, and Indian Geotechnical conferences were held in 1984, 1992, and 1999. The greatest achievement of the study circle is the hosting of the 13th Asian Regional Conference on Soil Mechanics and Geotechnical Engineering, held under the auspices of the Indian Geotechnical Society and the International Society of Soil Mechanics and Foundation Geotechnical Engineering in December 2007. Presently, Kolkata chapter operates from its own office premises at Vaishnavghata, Patoli Township of EM Bypass, Kolkata. Our present vibrant young team aims at promoting cooperation amongst the engineering fraternity of academics and industry for the advancement and dissemination of knowledge in the broad domain of geotechnical engineering and allied fields and their practical applications. Well, this is all for now. Over to Pranav.
Thank you so much, Dr. Abhijit Saha, sir, for a wonderful introduction about IGS Kolkata chapter to the audience. Now I welcome Professor J.J. Mandal, who is chairman of IGS Kolkata chapter, to give introduction about the workshop speakers to the audience present here. Professor Mandal, please. Professor Mandal, you are on mute in case you are speaking.
Good morning, everybody. I am delighted to introduce the eminent speakers for today's workshop. We have with us Engineer Shyamal Mitra, a prominent geotechnical consultant and CEO of SK Mitra & Associates, Kolkata, India. Then we have Dr. Martin Larisch, Director, Larisch Consulting Limited, New Zealand. Then we have Mr. Ian White, Business Unit Manager, Menard, Middle East. Mr. Prathmesh Wani, Geotech Engineer, Menard, Middle East. Mr. Anirudhan, IV, Geotechnical Consultant, Chennai. And we have with us Dr. Sunil S. Basarkar, Vice President, Afcons Infrastructure Limited, Mumbai. Now, I like to detail out the sequence of the seminar workshop as it will come. It will be started by deliberation of Mr. Mohan Ramanathan, who will talk on the overview of DFI activities in India. Then our first speaker of the technical session is Engineer Kumar Mitra, CEO, SK Mitra and Associates, who will be talking on pile foundation design and construction practices with typical reference to piling in West Bengal and northeastern states of India. It will be followed by deliberation of Dr. Martin Larisch, Director, Larisch Consulting Limited, New Zealand. We will be deliberating on CFA pile, construction techniques, global practices, followed by a dual deliberation of Mr. Ian White, Business Unit Manager, Menard, Middle East, and Mr. Prathmesh Wani, Geotech Engineer, Menard. And our fourth speaker of today's workshop is Mr. Anirudhan. He will be talking on design approaches for CFA files. And the last and the most important speaker of today's workshop is Dr. Sunil S. Basarkar, Vice President, Avakian Infrastructure Limited. He'll be talking on CFA files, methodology, DFI India trials, suitability, and applications in India conditions. At the end of the technical sessions, acknowledgement and concluding remarks will be delivered by Dr. Sufiya Khatun, Associate Professor, Alia University, West Bengal. This is from my side. Again, I welcome all the participants to this workshop. I think they will be benefited and we will also be benefited by sharing our knowledge. Thank you.
Thank you so much, Professor Mandal. Now, I kindly request Mr. Mohan Ramanathan, sir, who is Chairman DFI of India, to give a short overview of DFI India activities.
Good morning to you all. This is a great day for IGS Kolkata chapter and for DFI India. I'm as chairman of DFI India. I welcome all the delegates, the registered delegates, the dignitaries from the IGS Kolkata, and the students for a great day of learning. DFI India, or DFI of India, as it's called, is incorporated 2013. As you can read most of the text, I will just highlight. We are affiliated to DFI USA. DFI USA has more than 48 years in existence in New Jersey, in the United States. And it is a great platform to become a member of this and interact and benefit by many of their activities. Next. So what's DFI India mission? We have a holistic approach, and as a non-profit organization, we promote technology, we give a platform, and anything new technology which can be adapted to India, we identify, we do the research, and we bring it in. We are a great portion of our activities in training. So we identify which are the training gaps in the industry. We work with manufacturers, we work with owners and consultants and contractors. We also have a student outreach program, very successful student outreach program, which any of you students can join. And we have women empowerment programs. So Women in Deep Foundation is a separate activity. We always encourage them to join the Geotechnical fraternity. The highlight of being of DFI India is our conferences and other technical programs. A snapshot of our executive committee and the in India, which is very active. We have 21 members. As you can see, we have a mix of manufacturers, consultants, academicians, and this technical committee steers the decisions that we make. Then we have technical committees, which which directs our activities. The membership. So we live on the membership, and the membership, we always keep appealing for memberships in a membership drive. You can all visit our website, dfi.org, members, And apart from our normal benefits, we have access to online.org, onemind.org. This is a vast technical library of more than 125,000 technical articles. It's freely available for all members. So this is, I encourage you to go and visit this site link, and then you can benefit it. And we have technical committees which drive, and each technical committee has its own KPIs. And one such technical committee is the CFA, which is a huge one for us, headed by Chair Sunil Basarkar. And the result of this committee is today's workshop. And we'll have more such workshops in the coming years in other parts of India. So CFA piles, you will learn a lot about it today. And we have a very active committee headed by Dr. Sunil Basarkar. Yeah. So we also have a geotechnical characterization of a foundation committee headed by Dr. Parth Sardi from Bangalore. So this committee is also quite active. We conduct workshops, basically training and certificate program for lab technicians. We find that this is a big gap, that we don't have very qualified lab technicians, and we have great plans ahead. 5-day workshops. You are welcome to come and join these days and support these workshop practices. Then we have a student outreach by Dr. Umar Shankar, headed by Dr. Umar Shankar. So we have this groundworks webinar series. We had one yesterday also, or day before yesterday's. Groundworks is a series of talks that we have, and it's basically Groundworks is for students to benefit. So we had great speakers like the Dr. Harry Pulos, Kassenbach, Deepak Chaudhary, and so forth. And we have a lot more to come up in the coming years. The next committee, okay, this is still there. And we have awards for students. The next committee is the training committee headed by Avakian and Vaidya. So we take very specific and burning topics from the field, like reverse circulation drilling, efficient piling methods, support fluids. This is a great with the exploding activity of piling in India, and the support fluids. We used to use bentonite. Now support fluids have come in. We have training. We have a training program on tremi-concreting. This has been a very popular program, and we welcome corporates to engage us, to invite us to conduct this program for in-house. So this is headed by no other than Avakian and Vaidya, who the whole Indian piling industry knows. We also have other topics like ground improvement, and we are open to new topics. The future is work platforms. This is a big initiative for want of time and pushing. Then they recently formed a helical screw pile committee headed by me. And this is a brand new committee. We just got going from the subcommittee. We have plans to bring all the stakeholders in one platform and go the CFA way. This is a small solution, but not yet arrived in India. Just like underneath pile was a revolutionary thing in the 70s. I hope that our activities and the publications that we will bring in will help the piling industry in India. Going forward, we have the Women in Deep Foundation India program. So this is unique in the sense we get all the women involved in geotechnical engineering. Mostly it's from the design office, and very few there are entrepreneurs. We try to bring everything under one umbrella called WDF India program. And it's always part of our annual conference. There's always a session, a half-a-day session by engaging them. I invite all the girls or women in this workshop to join this program and benefit. Now, our annual feature and the crown in our activity is the annual conference. So last year we had it in Vadodara. It was a grand success. In this conference, were held over 3 days, 5th, 6th, and 7th October 23. And you can see the statistics of this conference. It's a grand success. We have keynote speakers from all over the world, and also published by Springer later. So this is something that we look forward to every year. So DFI at Baroda was a grand success. We had the chief guest was Mr. Giridhar of Afghans, and we always have an exhibition along with it, and we look forward to support from the industry. As you can see, the small logos of all the supporters, and they are the backbone for DFI's activities. So this is a lookout for this conference, which is coming up in 24. On the 13th annual conference will be held in Goa. Here is a simple flyer showing the dates. Please block the dates. This is a prestigious conference. You must attend it. You will attend. You'll not only benefit. Each one will have looked for something else. You look at new products, or you'll network with the best in the field. You look at new manufacturers. You will interact with academia and so on. Please mark the dates. It's 19th to 21st September in Panaji in Goa. So this is along with IGS Goa chapter. We co-organize. Here's the snapshots of the venue. It's a huge conference hall. It's a well spread out place, and you will enjoy not only the conference but also the hospitality of Goa. We already have a full active committee going. Conference committee is chaired by Dr. Savaikar of IGS Goa chapter, and we have the technical committee chairs are Dr. Musarkar and Jay Kumar. The conference program, speakers, technical program, cultural program are all under discussions, and it will soon come out. At this stage, we have called for abstracts, and we have an overwhelming response of abstracts. Registrations are on. You can go ahead and register yourself on the website. So we already have 175 abstracts, and the challenge is to choose the right ones for the conference theme. And you can see more about it in our conference website. So that's all I have as from the chair of DFI India. I wish you good learning and a happy half a day of intense geotechnical learning. Thank you very much. Over to you, Pranav.
Thank you so much, Mohan Ramanathan sir, for your overview of DFI of India activities. Now, I request Dr. Abdur Rahman sir, who is Assistant Professor in Jadavpur University, to kindly moderate the first technical presentation of the day from Mr. Shyamal Kumar Mitra sir. So, Abdur Rahman sir, over to you for this session.
Good morning, everyone. So we are going to start our presentation session, and the first presentation will be on pile foundation, design and construction practices with typical references to piling in West Bengal and eastern states of India. And this will be covered by Engineer Shyamal Kumar Mitra. Engineer Shyamal Kumar Mitra is the CEO of SK Mitra and Associates. Mr. SK Mitra has graduated in civil engineering from Bengal Engineering College, Sirpur, West Bengal, in 1967, and served the state government, followed by a long stint in a private geotechnical engineering firm. He finally established his own consulting business since 1992 in the field of geotechnical investigation, surveying, NDT on piles and structures, handling distresses at construction sites. He serves as an advisor, helping out in designing foundations for various types of structures, both residential as well as industrial or infrastructure. His firm is well respected for ethics and reliability. So with this brief introduction, I welcome Engineer Shyamal Kumar Mitra, and I request him to start his presentation. Over to you, Mr. Mitra, sir. SK Mitra, sir, please start your presentation.
Am I audible?
Yes, sir. You are audible.
Yeah.
So please share
Am I
your
visible now?
sir, your screen is not visible.
Am I visible or not?
So you are visible. Your presentations.
I'll share my presentation. Is it visible?
Not yet, sir.
Just a minute. Is it visible now?
Yeah, yes, sir. Make it full screen, sir.
Is it okay?
It's fine.
Om Sri Gurube Namah. Om salutation to my Guru. Good morning, good afternoon, good evening, depending upon where you are listening from. I am thrilled and feel privileged to be invited to deliver a presentation in this particular important seminar. And thanks goes to DFI India, IGS Kolkata chapter, and especially the chairman of Kolkata chapter, Dr. J.J. Mandal. I was given this particular topic to talk about, but then I was also wondering as to what should I talk about, because the general, it is a very general topic, and I thought I should choose a particular more focused issue for this deliberation. Before I do that, I thought I will share with you, particularly for overseas listeners, the brief scenario of the current practices in this part of the world, where we are on a Bengal Delta, where a rock is available at a depth of around 10 kilometers from the surface. And it has a thick pile of sand and silt, and we are supposed to deal with it with the growing demand of infrastructural and other kind of construction. Now, what are the types of piling which are popular here in this region? Timber piles are still used. You may be amused to know that, but these timber piles are still used for many effective reasons, particularly because water table is very high here, and decay of wood underwater is well known to be very slow. So we have what for groundwater, ground improvement, as well as for foundation support. Of course, for very small kind of loading, not so tall buildings, etc., and boundary walls and things like that. And also to arrest settlement of the foundations. Then we have driven cast-in-situ piles, which was traditionally been used for a long time in Kolkata. But nowadays, it is limited to non-urban area because of pollution and vibration. But wherever possible and soil condition permits, we are trying to use it for both foundation support as well as for ground improvement. When board cast in situ piles is used for foundation support and shoring walls. When I say board cast in situ piles, in some part of the globe, it is called drill piers. These are used mainly for shoring, the support of the excavation as well as for foundation support. And we have from very small diameter, 450 millimeter diameter, to over 2.5 millimeter to 2.5 meter in certain cases, and length, depth varying from a shallow depth of 20 meter to over 60 meter. Now, apart from this, we have just introduced CFA piles of 600 mm diameter, and it is being used presently for ground improvement in one of the sites. I think this is a beginning, and it's a good idea that CFA experts are here. We'll hear more from them. Types and processes, just to quickly glance through the processes, particularly for overseas listeners. These are tripod rigs, and they use a direct mud circulation system for boring, and it is very widely used all over India, even now. And the diameter up to about a meter and a half has been done with this. Then, of course, you have nowadays these rotary piling rigs. They have a mechanical auger, a bucket for boring, and boreholes are supported by drilling fluid, usually polymer these days. Then you have tire-mounted drilling rigs, shortly termed as TMR. Now, these are they used either direct mud or reverse mud circulation for boring process. And it is basically, we must understand, it is basically made for water well drilling and not for piling. But they are used in some of the piling sites. And then this is the first rig that we have in Kolkata in operation. This is an actual site photo. And of course, the non-displacement boring method for and filling up of hole during withdrawal, etc. And no rebar is being used at this particular site because these piles are being used as designed as stiffening elements to improve the ground condition. With this background, I had introspection on what to talk about on a subject so well researched and documented. There's nothing much to talk about it in front of the experts. It's okay for beginners, but not for the experts. So I chose a subject basically to focus is this. This is a relevant topic, which is a reality, but scantily reported. And that is performance of large diameter board piles with high end bearing component in alluvial deposits. As I said, we are having rock at a very, very deep depth. So we cannot take the advantage of founding the rock in that kind of solid rock. But then we are constantly under pressure to design piles of high capacity. Because of the demand for high rise buildings in Kolkata, we already have 60-story building, and other buildings of similar height, almost similar height, are also coming up. And then with this kind of soil, the challenge is, as you can understand, is very, very big. And the land available is often very small. So the footprint being small, the aspect ratio of the building becomes very, very uncomfortable at times. And you are compelled to use high capacity piles. The problem is to construct that kind of piles with certainty. And this is the topic I would like to bring forward for your deliberations and share our experience so that you can come up with certain solutions, maybe with new type of piling process. So usually the problem is underperformance of the piles at present, and we'll deliberate on that. The problem faced are underperformance of the piles during the load tests. The end-bearing component is not mobilized. Confusion arises in dealing with the issue and finding a comfortable solution. And delay in completion time, contractual issues, and of course, cost overrun. Following areas of concern can be pinpointed. Soil investigation reports are not of requisite standard, unfortunately. Not always, but sometimes, more often than not. Scanty exposure of the designers to the various processes available for construction of both piles and their applicabilities. Now, so far, the designers in the designing office, they have very less exposure to the actual practices and the sensibility of the different processes to the performance of the piles they design. These small capacity piles were much easy to design because you can do away with any end-bearing component, and we used to do that all these years, deriving the capacity through skin friction alone. And then but now absence of any geotech engineer is also a big point in decision-making process at design stage. The geotech engineering concept has not yet been fully understood, that you need specialized input at the design stage, particularly the parameters that you take and the process you would like the clients to adopt. These are not known to the designers because they spend very less time at sites. No geotech engineer at site. Nowadays, it's unfortunately, engineers are not available because mainly with the interest in doing more of white-collar jobs, maybe. In our time, we used to be at site all the time, but at least for 20 years of my earlier career, I spent that time mostly at site. There was not a single investigation site, soil investigation sites or piling sites where graduate engineers were not posted. I still remember way back in 80s that there was a site in Western Nepal in a very hostile terrain. There's nothing within 100 kilometers. It is inside a jungle. And we were investigating for foundation for the longest cable, single span cable stayed bridge in those times. And when I visited the site and stayed in the camp with my engineer there, I also found that one Dr. Nichols was posted from the client side full time, and he was staying another 10 nearby. And he was there full period of the investigation. That was a kind of, seriousness that we used to have. But unfortunately, although the problems are more nowadays, we have less engineers at site. And then utter lack of technically backed piling agencies, unless the project is big enough to attract big players in the field. Medium level and smaller contractors, they just don't have any technically backed personnel with them, and they act more like a labor contractor with some equipment in hand rather than a they're not technically backed. Technical competence is often not given due weightage while selecting agencies for such specialized work. This is also another point which is important. And what are the solutions from the design side? That's what I felt, and I thought I'll share with you. And from design side and from execution side. From design side, to be fully conversant with the subsoil properties of the site by thoroughly studying the geotechnical report, looking for variations, order additional investigation if needed, it is worthwhile to take help of a geotech engineer at this stage and choose design parameters. Then understand the machinery and methodology to be used for the piling work and specify your preference. This selection is extremely important as one needs a neat hole up to the desired depth with a clean base. That is basically the requirement. This is the basic requirement, and this can be achieved by proper machinery and methodology only. The designer must specify his or her choice of both clearly in the design basis report. Then it is to be understood that design of large diameter, high capacity board cast in steel piles cannot be successfully done by only following the guidelines given in IS 2911 alone, but needs careful design considerations as well as experience, equipment, methodology, and quality control of the piling agency and supervising staff taken all together. It's a joint collaboration. Adopt the procedure as per BIS code for both end bearing and skin friction to design the pile, but ensure that the shaft is taken at least up to 3D into the dense bearing stratum. Do not consider any end bearing component at all if high class supervision is not expected. Major setbacks are often faced due to serious mismatch between predicted behavior of piles with actual, and that too at a rather crucial stage of the project. If you have to mobilize end bearing, then act as follows. Include a full-scale trial bore to check the adequacy of the equipment and methodology of the intended piling work in the specifications of the contract doc. This test is very important, in which actual stability of bore and sedimentations in the pile base are checked periodically over a sufficient time gap that is expected between end of boring and actual casting of the pile at the particular site. This is important, and we do this nowadays. Also specify that the agency will only be allowed to cast the initial test piles after successful completion of this trial bore. These bores shall be filled up with sand immediately on completion of the tests so that no one should fall accidentally in the open borehole. Now, this I thought is important to point out as should be part of the contract document, because I have seen mishaps. Do not provide any L. This is the usual mistake that you make in the main rebars at the bottom of the cage, as this is counterproductive and prevents proper sweeping of the base during concreting operation. Provide access pipes for cross-hole sonic logging in each pile. The designer should demand an initial load test to validate and fine-tune the design before constructing any working pile. There is always a tendency to jump to the working pile to begin with from the owner's side. Loading during the initial test shall be at least 2.5 times the design safe load. If the designer feels that the actual parameters of the pile is expected to be better than the recommended values arrived at this stage, he should ask for higher reaction for the initial test and extend the test beyond the final load originally planned for. It has been found more often than not that a well-executed pile performs better than theoretical prediction. The contrary is also painfully true, and piles with high end bearing component underperform often during initial testing. All depends upon the preparation of the bore. Causes of failure can be easily identified with the instability of the pile bore, improper use of drilling fluid, inadequate cleaning of the pile base, faulty trimming operation, and improper slump of concrete. From the execution side, deploy only adequately powerful and dedicated hydraulic board piling rigs along with properly designed cutting and base cleaning tools. It must have a functioning console to record verticality, depth, system pressure, etc. We often find that the torque required is not matching with the equipment brought to site, and that should be avoided. Standard DMC rigs are not advisable, and truck-mounted dipole rigs are not to be used at all for the construction of such high-bearing, end-bearing kind of piles. Inspector should inspect the cutting tools, its OD, air vents for avoiding piston effect, bottom cleaning buckets, etc. The manufacturer's original accessories are well designed, but very often locally fabricated tools are used, which are not designed properly. The people at site must be adequately trained to supervise board piling operations, complete with QC, safety, and use of consumables, etc. Use of polymers with proper additives is recommended for achieving better quality pile bore as well as the best stability, apart from the fact that it is more eco-friendly. However, full-time technical supervision by the polymer supplier during the trial period must be made mandatory. He will not only check and approve the machinery, tanks, and pipelines for the slurry preparation and distribution, but also fix the doses of polymer and its additives for the site and stay put at site till a slurry of satisfactory quality is produced routinely. Then the executioner should have total control on the quality of preparation, distribution, and records of the drilling slurry. Piling Supervisor's Handbook published by DFI and other government, state, professional bodies should be followed strictly for the proper construction of the pipes. Slurry samples for checking the specific gravity shall be collected from the base of the pile prior to concreting operation and not from the slurry being flushed out at the ground. And the tendering process as a standard process, tender should contain the soil investigation report and the targeted pile capacities, and the bidders must satisfy themselves with the data and the expected capacity and quote their prices. They will be encouraged to reconfirm soil data on their own, but submit their offers based on their design. Best offer from both technical as well as commercial side should be awarded the job. In such piling works, the contractors will have to take the responsibility of producing the piles as committed, and therefore must have adequate technical prowess to negotiate technically prior to award of the job and produce piles with guaranteed performance. Two typical cases are presented here. In case of sandy soil, the performance of an end-bearing pile will either be a disaster or satisfactory. There is no intermediate stage, unfortunately. Two case studies are presented now to show what the difference can be like. These are real-life cases, and for obvious reasons, no details of the project can be revealed. In both, piles were resting in dense sand and designed to have a high end-bearing component. Case one, I'm not going through the detail, it will be paucity of time, but then all the piles, these piles were 1,000 mm in length and about 33 meter piles were constructed. The first pile, test pile, failed, and you can see the length was increased by 3 meters, but that's not the reason for its performance. As you can see in the next slide, the load settlement graph. Just have a look. There's no match at all. You can see the bottom thick black line represents the test pile, and it failed in between 300, more or around 300 ton, whereas the properly executed pile is nowhere near failure, even at much higher. And then the next site is also, it is basically, this is where the pile was kept. It's 750 mm diameter, 33 meter long piles, routine, three routine load tests were conducted on working piles because we were called in when the working pile was going on. And then after two routine load tests failed, we were called. And then after improvement with the same equipment, same design, I see the difference. The bottom two, blue and the orange ones, are the initial two pile where it failed miserably here. But the other one is nowhere near failure. This is a kind of, drastic change you can effect. Designing of end-bearing piles, conclusions are board piles without considering the hardware and quality control requirements is not a safe and proper practice. Site personnel with piling experience is an absolute necessary. Such persons are almost non-existent now. Economic considerations often sideline the need to provide strong focus on the quality of construction of the vital part of the project, and which is constructed almost blindfolded. Badly designed and supervised piles can cause bad investment of a large order, and there is huge scope of saving resources by improving the design and practice. Recommendations: foundation designers and geotech engineers must spend more time at site and be conversant with the hardware and its effects on the pile behavior. Raising of a cadre of piling engineers should be taken up seriously by bodies like DFI. A certificate course should be started for grooming piling supervisors who will be going through theoretical as well as site training before award of a certificate, and certificate personnel should be gradually introduced as the only authorized hands working under the site heads. Agencies with technical competency should only be considered for tendering process. Agencies must take full responsibility of the performance of the piles. And these are, I've given us a brief outline of the course content. Mind you, I have tried this out. This is not theoretical. I've tried this out with my company. It worked very well. Concluding remarks: problems and solution of end-bearing piles have been discussed. Need for technically competent piling agencies have been highlighted. Need for trained professionals have been highlighted. Industry will be happy if newer systems like CFA piles or base grouting technique can produce end-bearing piles with more certainty. Be responsible, design well, save resources, and save environment. Thank you very much for your kind attention.
Thank you, Engineer Kumar Mitra sir, for the wonderful presentation. Now the session is open for question and answer. So I request the participant to please type your question in the Q&A box. So there are already a lot of questions, so we have 10 minutes. So I will take the question one by one. Sir, I will read out the question for you and you can answer it. So the first question is from Gautam. The question is, if the pile is performed very well, will extrapolation is allowed till the allowable settlement criteria to estimate the real pile capacity? So is the question clear to you, or I should be? Sir, you are mute. Mitra sir, you are mute. Please unmute.
Yeah. Am I audible now?
Yes, sir.
Yeah. It depends which load test card we are talking about. Is it initial load test or routine load test? If it is initial load test, of course, you have to normally have to arrive at the failure load. That's what we always like to have, because in case of sand, it can be shear failure, which can be abrupt. So, but if it is a routine load test, of course, you can extrapolate if you have in the background the initial load test curves.
Okay, thank you, sir. The second question, this is from Engineer Kumar Mandal. He has asked, sir, what are the methods that should be adopted to clean the base of large diameter pile board in addition to the cleaning bucket, especially in case of offshore condition?
Well, offshore is a different ballgame altogether. They have much more sophisticated equipment, but generally onshore, I'm talking about, the use of additives at the end of boring to settle down the floating sand particles quickly is a mandatory step to be taken. You have to wait for half an hour to 45 minutes for these particles to settle down, and then use a cleaning bucket. That should be adequate. We have also experimented with introduction of a RCC disc at the end of the pile rebar cage to be lowered to have a firm contact with after the pile bore is cleaned, and the results have been very satisfactory. But it is too premature to pinpoint and attribute the success to the addition of that disc. But in every case we have used the disc, it has been served very well, acted very well. Yeah.
Okay. Thank you, sir. The next question is from P.S. Sengupta. This is a very long question. What is the reason for defective piling? It is not lack of advanced technology and use of stabilization fluids. I am not against the adaptation of advanced technology, but unless there is a proper quality assurance and engineering ethics, pile failure will happen. Main problem is with lack of quality assurance. If we use bentonite solution of substandard quality or do not care for pile hole bottom cleaning, the punishment is bound to come. A quality job can be done in piling even using Weller and chisel method, but with all precautions as given in IS code of practice like proper bentonite management, cleaning of hole, creamy concreting, etc. So the question is, if IS code specifies use of 0.8% minimum reinforcement throughout the pile shaft, how are we going to follow this in CFA pile?
The various questions in one go. First of all, the first part, I am more than happy to accept whatever is being said. It is all about quality control, of course, and one should be aware as to how the pile shaft behaves, and and how to clean the hole to your satisfaction. And quality control, I've been emphasizing this throughout my talk. If you have noticed it, that is how it should be. But CFA pile, we will know more about it as the day passes. After this, we have expert speakers on the subject on CFA. I will rather wait for their deliberations. I think you will get your answer.
Okay, sir, we have a lot of questions. I will take few of them. The next question is from Abu Dahir A. The question is, what is the maximum or restricted angle of internal friction you will consider for very dense sand?
We have been using with success N values without any correction. Because you see, you have to develop regional database, and blindly following a particular textbook doesn't help. Unless you you have your own database. So we use certain correlations and come up with phi angle as high as 40, 42 degrees sometimes. But usually for both pies, we are on the defensive side, on wrong side of 40, the lower side of 40 would be the maximum, like 35 degree to 37 degree we have used for, again, it depends upon the grain size, distribution, and the angularity and origin of the soil. I think we have to deliberate on this for hours. It's not 1 or 2 line answer, but yes, you can take high values depending upon the type of sand that you have. There are various types of sand. At this stage, it will prolong the discussion otherwise.
The next question is from Samogna Dasgupta. First question here, 2 questions. First question is, what is the pile behavior in silty soil, especially from end-bearing point of view? And second question is, why there is no stringent guideline for bottom cleaning in IS code?
Well, the first point is a very generalized question, whether it is silt, sand, or clay. But for clay, we don't find much contribution, and the silt can be either plastic silt or non-plastic silt. So you have to qualify what kind of silt. Again, it's a discussion which can better be done across the table than not on a question and answer session, because that's a subject by itself. Silt is a very tricky material to deal with. So I would not like to elaborate on this. If we can meet sometimes or over phone, or that will be the right platform for this discussion.
Sir, the second question was, why there is no guideline for bottom cleaning in IS code?
Well, I'm not a part of the IS code maker, so I won't be able to answer this question at all. But I guess IS code is a very good code. It should include more about this process of piling with rotary rigs, I'm sure. It will come.
We are running out of time. We'll take 1 or 2 questions. The next question is from Madhuri Samachula. What are the other alternatives for piles that can provide better strength for the structure?
Say that again, last line.
What are the other alternatives for piles that can provide better strength for the structure?
Well, this is, I think it's talk about non-pile solution. If it is non-pile solution, then you have to replace soil with maybe jet grouting and deep mixing. We have found very, very important and heavy construction being built on silty soil, which has been completely replaced by deep mixing. That's possible, but that's beyond the scope of this seminar.
Okay, so this is the last question we can cover. This is from Rajan Peter. The question is, what about testing of pipe bore by ultrasonic monitors?
What does it mean? Normally, borehole calipers are available to check the diameter and shape of the bore that has been made. But ultrasonic test for what? Is it for, but unless you cast the pile, what will ultrasonic test do? I'm not clear on this question, actually.
Okay. Thank you, sir. We have a lot of questions, so we apologize from the participants that we cannot address all your questions because of the timing issue. So now I am again thank you, Engineer Mitra sir, for the wonderful presentation and giving the answer of the questions. So now I am handing over this session to Mr. Pranav.
Thank you very much. Thank you very much indeed. I'm happy to be here. Thank you again. Bye.
Thank you, sir. Over to you, Mr. Pranav.
Thank you so much, Mitra sir, for a wonderful presentation, and Dr. Rahman sir for moderating the session and keeping it on time. Now we move ahead, and may I request Dr. Subhadeep Mehta to moderate the next technical talk by Dr. Martin Larisch. Dr. Mehta is Assistant Professor in NIT Jamshedpur. Dr. Mehta, please.
Yeah, very good morning to all of you. It is my pleasure to introduce our next speaker today, Dr. Martin Larisch, who is the Director of Larisch Consulting Limited, New Zealand. Dr. Martin is an independent geotechnical civil engineer currently based in New Zealand with more than 25 years of technical and operational experience in geotechnical contracting, consulting in countries like Germany, Australia, New Zealand, and throughout Asia. He holds MSc in Advanced Concrete Technology from University of Leeds, UK, and PhD in Geomechanics from University of Queensland, Brisbane, Australia. He is an ISS MG representative from New Zealand for the various technical committees like TC211, ground improvement, TC212 on deep foundations. He also worked as an adjunct professor at the University of Queensland, Brisbane from 2014 to 2021. With this brief introduction, may I now invite Dr. Martin to deliver his address on CFA piles, its construction techniques, and global practices. Over to Dr. Martin.
Thank you, Dr. Mehta. Thank you, everybody, for the kind invitation to be part of this webinar. It's a great honor. Thank you for particularly for DFI India and the Kolkata chapter. It's a great honor for me to present today. I will share my screen. Please let me know if you can see my screen.
Yeah, you can continue.
Perfect. All right. So my presentation will be about CFA piling construction techniques globally. I will focus on this part of the world where I'm currently working. We're using a lot of global practice from the UK, from North America. Hence, I want to probably be a bit careful rather than calling it global practice, Australia, New Zealand practice in particular, but we are relying on a lot of global advice. Basically introduced myself already. Thank you for that. Maybe one aspect is when I did my PhD, I basically worked for about 2 decades for various piling and ground improvement contractors. Frankie Pile in Germany, then spent a long time for Keller, did some work for Menard in Germany using CMCs. And I did my PhD on installation effects of drill displacement columns or drill displacement piles, because I've seen a lot of construction related effects on site, and I did that in part-time with the support from Keller back in the days. And I think it's really important to consider installation effects, particularly for CFA piles, which can influence the performance very significantly. I want to start with a bit of health and safety consideration, particularly when we're talking about CFA piles. We see a working platform here, and I'm also a member of the DFI EFCC working platform group. Working platforms are there for piling rigs to operate and to work, so they need to have robust designs, but they also need to have economical designs. Thing is, it's really important or the FPS in the UK and the affiliated branches worldwide suggested that around 1/3 of all piling related incidents are platform related, and all of them are potentially fatal or catastrophic. So keep that in mind, particularly with CFA piles. We will see that in a few minutes. They have slightly different bearing pressures because the drilling motor sits up the mast, so they're not as balanced as most of the rotary piling rigs. All right, I will talk today about introduction and background of CFA piling. general construction aspects, design principles, just a few slides about codes and standards. There will be another presentation later on talking more about that. Then about concrete technology, very important for CFA piles. The deeper the pile, the more important the concrete mix will become. Construction monitoring, quality assurance, and some selected construction risks. What I just mentioned, in the design, we can have the best design codes in the world, and as a designer, we stick to them. But in some instances, ground conditions may be very unfavorable, and even the best contractor in the world can't construct a pile with, for example, impacts on shaft friction or end bearing, particularly with CFA piling. Again, there's nothing wrong. It's just awareness when we design them, when we construct them. And as designers, we have the power to put specifications into place and to specify certain things if we want to see hold times or other QA-related aspects. All right, let's start. Scope of this webinar. So CFA piles or continuous flight auger piles. They're new tech or their technology we use to install plain or reinforced concrete columns into the ground. CFA piling can be very efficient, cost effective, but there are a few risks related, particularly with design and construction, that is slightly different than for board piles. The end of the day with CFA, we will construct a board pile of a certain depth and diameter, and we could install a similar board pile with normal rotary board piling techniques. So we're not installing a different product. It's just the way we install it is very different. And in the next half an hour, I will introduce a few of these differences and also highlight a few risks mainly related to construction. However, it's not fully comprehensive, and we won't have time to address all relevant risks of this technique in this short webinar. Just a few design codes, don't want to get too much into it. There's the design and construction aspects, FHWA, has this Geotechnical Engineering Circular number 8 for the design and installation of CFA piles. And of course, in my part of the world is AS 2159, so the Australian standard for piling and design installation. And both documents allow that CFA piles can be designed with either full-length reinforcement or partially reinforced. So when I'm talking about deep CFA piles today, or CFA in general, there's always an opportunity to install them partially reinforced, depending on your load cases. Where I live now in New Zealand, we have earthquakes, we have soil liquefaction. It's almost impossible to design piles without a full-length cage in these conditions. And this is the problem. We will see shortly with CFA piles, we need to plunge the cages into the fresh concrete. If you have a 20-meter long cage, it can be very, very difficult to get the cage down. The majority of the high-rise buildings in Melbourne, for example, and they're all sitting on CFA piles. The piles are 40 to 50 meters deep, 120 to 150 feet. Very deep piles, but they only have small reinforcement cages at the top. The majority of these piles, when they only experience compression loading. So that's very important for the applicability. And then a very good construction specification is from the Institution of Civil Engineers in the UK. It's SPERBA, or the specification for embedded retaining walls and piles, from 2017. And the CFA section is very comprehensive. It's a very good document, and definitely worth reading. One important thing on the right-hand side, I put a figure from the Australian piling standard AS 2159, and it says that CFA piles are non-displacement piles because they are excavating the soil, and the soil on a continuous flight auger will keep the hole open. I will talk about the installation methods in a minute, but I just want to briefly introduce AS 2159 because it's a quite unique code and heavily used in this part of the world. In order to assess your geotechnical strength reduction factor, the code requires you to make a risk assessment. Risk assessment including ground conditions, design and installation and construction verification. So depending, for example, on my geotechnical complexity of the site, my extent of ground investigation, amount and quality of geotechnical data, I have different weighting factors, but I also have different risk ratings. And then I can look into ground conditions, design, but also installation and construction verification. And based on this assessment on a project-specific basis, I can then come to an overall risk category. And for example, if my category is my average risk rating of ARR is, let's say, 4.2, and it's moderate to high, and I have to use my geotechnical reduction factor of either 0.45 or 0.53. And that depends on the redundancy of my system. So for example, if I have a bridge with a single pile, with a monopile, this pile is out of position, regardless if it's a CFA pile or a board pile. My redundancy is low. When this pile is out of position, I have a big problem. If I have a pile group, a pile cap with 16 smaller diameter piles and one pile doesn't perform as good as I want him to be, no problem. I probably have 15 other piles that can help to make that work. So this is depending on the redundancy of my system. I have different strength reduction factors. If I do pile load testing, I can increase these factors. Again, don't want to get too deep into AS2159, but I like the standard because it's a very dynamic system and very risk orientated. And if I accept certain risks in my job, and I had clients, they say, no, we don't want to do excessive ground investigation, you get the basic, and then we just applied a lower geotechnical strength reduction factor. So my geotechnical pile resistance got higher, we had to drill deeper, but clients were happy with that. So again, there's no right or wrong, it's just an interesting different method. Looking at construction sequence of CFA. We have piling rigs, that's the good news. They have to sit on a safe working platform, that's required. And then we start drilling, that's step number one on the left-hand side. Just start drilling, rotate the auger with a certain penetration rate into the soil. And whilst we are digging, the soil will be trapped between these auger flights. It's basically like a screw. And when we're going further down, this soil inside my auger flights keeps the hole open. So we don't need casings, we don't need polymer, we don't need bentonite for CFA piling. We just have to make sure that we keep our rotation of the auger at a minimum speed and a minimum penetration rate. So if we do that, we can then drill down to the design depth. That's step number 2, for example, 10 meters. When we're down at 10 meters, we stop rotating. And then the operator can switch from drilling mode into pouring, into concreting mode. And then we have a concrete pump, and my CFA auger is hollow in the middle, and this open end is closed by a sacrificial cap, could be plastic cap, could be a recoverable steel cap or something like that. And then the operator starts pumping concrete with a concrete pump through this hose, and then the concrete will be fed through the hollow stem of the auger to the bottom of my auger. And once it leaves the bottom, the operator starts raising the auger very slowly. And the auger tip must always be embedded in fresh concrete. And then the operator extracts the auger without rotating. There are two possibilities, and it depends on the piling rig manufacturer. Either the auger is still and doesn't move at all, or the second one is he will spin it in the same direction as drilling. Never ever spin it in the other direction, because otherwise you would just relieve all the soil that sits on the auger into the fresh concrete. So either keep the auger still or rotate it in the same direction. It mainly depends on the cleaning mechanism of your piling rig. And then you basically, that will be done to the surface, and then the pile will be finished, and then the reinforcement cage will be plunged in afterwards. And these are the key elements. We can have, we call them DFA, drilled flight auger. Sometimes we call them drill displacement system. And I know there will be a presentation later on about CMCs and full displacement systems. It's the same piling machine, only the auger is different. The diameters are different, and these full displacement systems, in these days, they're mainly used for ground improvement, for controlled modulus columns or stiffness columns or rigid inclusions, which is the general term. But it's the same rig, the same principle. The only difference, and we see that here in the little sketch on the right-hand side, that we are displacing the soil. Go back to the sketch from AS2159, differentiation was between displacement and non-displacement piles. CFA is excavation system and non-displacement pile, but these displacement augers, they're displacing soil, so they are probably more like driven piles. But my focus will be mainly on CFA. All right, they're very suitable to medium to high loadings, mainly compression loading. We had 1050 millimeter in diameter, 45-meter board CFA piles in Melbourne, carrying 25 meganewton compression loading. Construction verification was extremely strong with lots of load testing, lots of computer monitoring, and we needed 100 MPa concrete strength because the concrete got the weak point. So it's all possible, but this whole development was driven by contractors, by design and construction contracts. So contractors really got innovative, pushed testing, and this is what the Australian piling standard allowed for. Rewarding pile load testing. You can increase your geotechnical strength reduction factor or reduce your factors of safety if you increase your testing. Standard augers, I don't want to talk about the very big and the very small stuff. The very big augers go up to 1.5 meters in diameter. Standard augers usually between 450 up to 900 millimeters in diameter and up to 80 meters depth. These big piles can be drilled up to 45 meters depth with partial reinforcement cages. I need to differentiate, or I suggest to differentiate between standard CFA and the really edgy deep CFA stuff. And when I worked at Keller, we differentiated between CFA and deep CFA. Deep CFA is like basically almost space flight. You know, you just have different levels of technology, whereas normal CFA is probably normal aviation with propeller planes. You know, it's pretty robust. You still have a high risk. You need to manage that, but it's not as complex. CFA piling is very efficient and cost effective. If we chase suitable bearing layers that are reasonably close to the surface, we can use it for foundation piles, but also for embedded retaining walls, for basements and retaining wall and permanent retaining walls. Particular secant pile walls for 2 to 3 level basements. CFA piling can be very efficient for standard rigs, 40 to 60 ton operational weight. So this is a big one, I think, of Fundex FX 3500. Hope I'm not wrong, with a 1.2 meter diameter auger. You see the massive size of this machine. Early in the morning, the top of the mast was covered in fog. It's big. You see there's the reinforcement cage. It's a 12-meter cage, relatively light. So in this case, piles could be installed very deep, but they were mainly in compression, so a short cage was possible. Ideally, you want to construct CFAs with a single stroke. You don't want to use couplers. The key efficiency of this system is speed. If you want to use CFA and you can change your pile design, what I did in the past, just increasing the numbers but shortening them if the ground conditions allow to do that. But that's the key thing. Not having to splice augers and not having to splice cages. This is the big thing. And with single stroke, I think the highest one with 900 millimeters goes up to 50 meters for these big rigs. But it's always a matter of how much soil will you get into your auger flight, and will the rig be capable of lifting it? So it's a bit of a match. If you increase your auger size, let's say from 900 millimeters to 1200, you have to reduce your drill depth because the rig simply can't lift the auger that is filled with soil. And then it's important to understand the mechanism. What are we doing if we're drilling CFA? So we are cutting soil. Soil will be cut at the tip of the auger, right at the bottom. And then the soil will be transported upwards inside the auger flights. And with, for example, DFA piles, with the displacement piles, we very quickly have this displacement effect where the soil is pushed into the borehole wall, potentially increasing the density and the stiffness of the surrounding soil. With classic CFA, we don't do that. We're just cutting and then we're transporting. Therefore, we need to have a minimum penetration rate of the auger. Otherwise, you remember these grain silos or cement silos, they have these spinning horizontal augers and they're used for transport. And we will see that later on. If we keep rotating our auger without adequate penetration, we will attract soil from the side entering it. We call that flighting or uncontrolled soil movement, and that needs to be avoided. This is one of another key risk of CFA piling. But how does good look like, particularly in sandy soils? We need to keep our penetration rate to a minimum. Rule of thumb, we said, if it's above 50% of the pitch height per auger rotation, we shouldn't get any flighting. So that means you see the CFA auger on the right-hand side that's filled with soil. Let's say that's a foot or 300 millimeters. You want to have at least 150 millimeter penetration per rotation. It depends on your soil conditions. If you're in soft rock, that's obviously not possible. But generally speaking, rule of thumb for loose to medium dense sands, for firm to stiff clays, you want to achieve that in order to minimize your risk of construction issues and side loading. CFA rigs are equipped with monitoring equipment. And sometimes contractors use the excuse, no, we don't have that. It's different than a normal board pile. As mentioned earlier in the brilliant presentation before this one, with a board pile, regardless if it's filled with bentonite or polymer, we can visually measure the depth. We can visually assess the cleanliness of the base, the diameter with calipers or other methods. For CFA piles, we can't do that. We have to rely on computer monitoring. We need to know about the depth of penetration rate. We also need to know about the concrete volume that was installed, because there's no other way of telling us. And this is just an example. They're attached to different positions at the piling rig, and they will give the operator very useful and necessary readings. For example, a penetration time and rate on the left-hand side. Again, this is just an example. Installation torque, concrete pressure, and concrete volume. This is very, very important as quality acceptance. And personally, I would not accept a CFA pile without that. There's always the odd pile when this monitoring system is damaged, doesn't work. But then we can always use manual reading and then stop piling and come back with a repaired system. General suitability for CFA piles, all type of structures with low to moderate and high actual loads. Construction of retaining walls could be secant or contiguous pile walls as on this picture. And usually piles with a single length or reinforcement requirement up to 18 meters. If you keep it to 12, that's a bit safer. I'm talking for experience in a highly seismic environment. There will be parts of India where this is the case, where you need full depth. It's not impossible, but you need adequate concrete technology. Secant pile walls, they rely on the interlock, and I just have a little animation here. You install your primary piles, the low strength concrete piles or the soft piles first, and then you fill the gaps with structural piles. And this gives you a very stiff retaining wall. The main reason for secant pile walls is also waterproofing performance for basements and so on. And you always want to have a primary or soft pile in the corner section. And this allows you to install the other two piles, the hard piles, in position. If you have a hard pile in position, it will kick out and you have to grout your corners. So as a designer, and if you design secant piles, always, never, ever have a fully reinforced structural pile in the corner. Been involved in too many basements that were leaking, and the grouting costs to fix that. If you're chasing a hole, that's always great money for the grouting contractor, but for the client, that can be a nightmare. We can use CFA in rock, soft rock condition. That's an example of a basement in Sydney. It can penetrate this rock several meters. but you need an adequately strong piling rig. That's absolutely critical, and have the right tooling. Again, there is no right or wrong. Contractors developed their own IP, their intellectual property, and but generally up to rock levels 5, 10 MPa, we can penetrate these rocks. General suitability in ground conditions for medium to very dense sand, so gravel, stiff to hard clays, all types of weak or weathered rock. We should avoid soil flighting above the rock. If this is not a problem, that's fine. If it's a problem, we should not do that. Installation below the groundwater table without casing or drilling support fluids, it's possible. We shouldn't use it for high strength rock because we simply can't penetrate it. With rock drilling, you have to apply adequate vertical force to crush your rock, and then you transport your cuttings. With CFA augers, we can't bring that vertical force onto the rock. Soft soil condition, my experience with undrained shear strength of less than 20 or 25 kPa, it's like you have this auger and you put it in a jar of oil, olive oil or something. You know, if your soil gets more like a fluid, you can't transport it through the flights. So use something else, maybe a driven steel tube, and excavate it with rotary method. Contaminated soil, that's the thing. You really want to bring it up to the surface, then we have to deal with it. Sometimes we have acid sulfate soils a lot in Australia. We don't want to touch it, leave it in the ground, and then we basically use driven coils. If you have obstructions like here, organic soils or changing strata can be a problem. Good news is we can do pilo testing for CFA piles. We can do PDA, dynamic testing. We see a testing frame here. That's for up to 1200 millimeter piles. If we test about 5 to 10%, and we use Australian standard AS2159, we can get reduction factors around 0.675, maybe up to 0.7 instead of 0.5. We can test, we can mobilize loads up to 10 meganewton with a 20-ton hammer. That's the rule of thumb with PDA testing. Whatever your test load is, you need approximately 2% of your test load as a hammer weight if you want to mobilize that capacity. If you want to mobilize 10 meganewton with an 8-ton hammer, that's impossible. You will probably get half of it if you are lucky. You have to build up these piles, so there's a bit of extra cost. There's an extra cost to bring this frame to site. That's an example. We need to extend the piles above ground level about 1.5 times their diameter. And then we may add additional reinforcement, bursting reinforcement, for example. And the hammer must hit the concrete, not the casing. That's very important. Sometimes you overcast that by 25 mil or an inch. Pile integrity testing can be done. We can use low strain testing, for example, PIT testing, very common for CFA piles. Often in this part of the world, we test 10 to 15% of working piles, mainly for buildings. For bridges, it could be every pile. Rock sockets, they provide a challenge that's probably outside the scope of this webinar. But because of a similar density of the concrete and the rock, we won't get a clear toe reflection. And cross-hole sonic logging is uncommon for CFA because we have to install the logging tubes to the reinforcement cage. If you look at concrete technology and testing, you need a very workable and very stable mix for your CFA. The reason is, like the piling crew here, they push the cages into the fresh concrete after installation. And this is really critical. This is the reason why we don't want to splice reinforcement cages. It takes too long. The concrete may go off. You may add some retarders or others, but that's not ideal. Ideally, you want to tailor your construction program, your material length to suit that. Ideally, the cage goes down by its own weight. Some instances, the concrete is too stiff and unworkable. We may use vibrators just to basically give it this last little whip to go down the last 1 or 2 meters. Or if we're stuck halfway through, get it out, get the cage out, re-drill the pile, and with a second go, the cage, in my experience, will go in with 99% certainty. Soft piles for secant pile walls should be not more than 10 MPa. their early strength development, or it should be late strength development, and lab testing should be carried out to assess the workability of the concrete. I would always use 10 millimeter aggregate, or in some regions 13 mil or 9 mil, whatever, but keep your aggregate size small because it's easier for the pump. Some piling codes consider at least 350 or 400 kilogram cubic meters of cement. Yes.
Dr. Martin, sorry to interrupt you. You have last 2 minutes for the
Perfect. Thank you. I will finish up. And then we could consider fly ash and other things to improve workability. There's guidance, DFI, EFCC piling, Tremie concrete guidance document, and in the Australian one. So whatever works for wet Tremie pour works in general for CFA as a starting point. Concrete supply is very important for operational things. So make sure that your concrete supplier can provide on an ongoing basis. This is really important. I normally use 4 hours working life. It's just for my jobs, but it's just because if you have heavy traffic, and it allows a bit of contingency. A few construction risks, I probably will skim through them a bit quicker. Working platforms, very important. CFA rigs have more bearing pressure than board piling rigs. And look at that, they can leave pretty deep dents in your platform. Concrete levels for CFA must be at working platform level, or maybe 300 mil down. If they scoop it out, plunge the cage, and then it will go up. You can't have deep cutoff levels with CFA because you will get necking if you do that. Cage spaces, we see that they must be installed. That's quite important. And in my design, I often allow for 100 millimeter concrete cover using 75 mil spacers. That gives a little bit of more room for installation. Another thing, probably the last point, a distance from the center line of the pile to a wall, to any vertical walls. We see that here very often. If we have a vertical obstruction, with CFA piles in particular, you have to drilling motor, and it just simply can't physically go any closer. So usually I take 900 millimeters or a meter from the center line to my pile to the edge of the wall. So that makes it that the piles can be installed. Contractors may have different bricks that can get closer. You may say, oh, look, this in front of the wall thing from Bauer. Yeah, but that's not applicable for CFA because CFA have the drilling motor on top. I've been there, and that's quite embarrassing if it happens. Probably one more thing, severe side loading. We spoke about that. If you drill your auger into hard clay, you have loose sand above. You just transport this loose sand to the surface, and this may cause settlement of adjacent buildings. Or the other way around, if you drill through stiff clay, you have loose sand down there, you will get soft toes. You won't get the resistance because you keep spinning the auger and create a big cavity down there. All right, so basically some more things about guide walls, and you will see that in the slides later on. Waterproofing performance, if you have basements, just a little bit of guidance on that one. Institution of Civil Engineers have a good guidance document. I heard some rumors that DFI is looking into that as well. Nothing confirmed, just something I heard. Maybe I'm wrong about that. All right. Summary, they are concrete piles. They're very efficient and a very good system. They have a few risks and probably a few more, but I try to highlight the key risks and opportunities. It's a fantastic system, but it needs to be treated with the respect it requires because things can go wrong.
Okay, thank you, Dr. Martin. We have a lot of questions to discuss. Let us take a few of them.
Yes.
Okay, so we can start from, yeah. Yeah, one question from Abhijit Kanangao, that how we can determine the minimum penetration rate of agar in different types of soil. Is there any guideline?
There's a guideline, and again, this is the ICE specification for piles and embedded retaining walls. It says up to 10 rotations per meter. In my opinion, that can be a bit much. It depends on your soil. If you have loose sand, for example, the rule of thumb I suggested is half per rotation. You have half the auger pitch. So if the distance of your CFA augers, let's say, is 300 mil, you want to penetrate 150 mil per rotation. That's not always possible, but there's a formula from Vigiani, and that's on a few of my publications, but it can be assessed early on. But rule of thumb, half an auger pitch per rotation, and the ICE specification for piles and embedded retaining walls provides guidance as well.
Okay. So next question from the same person, Abhijit, that yeah. So how do we? Okay. Is there any, I mean, SPTN value for that? I mean, the limiting value of SPT, or then any guideline, SPTN guideline, use the CFA pile?
Limiting value, unfortunately not. The old German piling code, before it was sucked up into Eurocode, it said your uniformity coefficient, if it's less than 3, you should not use CFA. And if your undrained shear strength of the soil is less than 20 kPa, you should not use that. Unfortunately, I only have this thing in German, the old DIN 4014, not translated in the Eurocode. But that's it from the lower end. From the higher end, it depends on your tooling. Typically, we penetrate SPTN values 50 plus in Auckland, where we have slightly weathered, moderately weathered sandstone, up to 5 MPa in UCS. You can get in, it takes some time, you can get a meter or 2 meters in, depending on the size of your rig, but there are no limitations typically. SPTN probably with 0, I wouldn't recommend it, and SPTN with bigger than 100 probably wouldn't work as well.
Okay. And what is the, I mean, one question from Ranathan, that what is the minimum spacing of CFA piles that would be adopted? Unlike the board pile, we might need to increase the number of piles due to depth limitations, especially the rivers.
Very good question. Depending on the ground conditions, if you do a test pile, I would start with soft ground conditions, maybe 10 diameters. If you do your first pile, the fresh pile, and then you do the one next to it, observe the concrete of the fresh pile. You see, if you're drilling, you see that if this concrete moves or drops, you see if something happens in the ground that may influence that. There is no rule, and there's no fixed rule, but I would probably start in really bad ground conditions, 10 diameters. If I have stiff clay or firm or hard clay, could be down to maybe 3 to 5. But again, site trials are required, and maybe starting in an area of this piling crew needs to set up. They have to do 1 or 2 test drills, and this is the opportunity on site to do that and get a feeling for it. But yeah, that's a very good point. I've done up to 10, up to 15D in very weak ground conditions. But you would observe that if your fresh concrete comes up, and that's, yeah, observational method is really go back to basics. And we have these highly computerized rigs, but looking at the concrete, if it goes up and down during drilling or concrete placement, is always an alarming thing.
Okay. And another question that from Bimal Siroy and some others also, that as we know that full length rivers is not provided in CFA piles, so how to measure it with its capacity without river, or is there any formula or any guideline to measure it?
Or the resistance?
Yeah.
Or the Geotech pile resistance?
Yeah.
Or based on your SPT or CPT, you do your normal effective.
Exactly.
Yeah. based on your ground conditions, or if you want to verify that, you use PDA testing. But you need boreholes below the depth of your pile toe. If you don't have that, there's nothing you can do, because you will excavate the soil. And if you don't know your ground conditions, very difficult to design anyway. But even without full-length reinforcement, you can do a PDA test. If it's only compression, you could do PDA with cap web to assess your resistance.
Okay. We have a lot of questions, but I think people can message you or email you for their clarification. And I have one question. Related to the risk-based design to CFA piles, is there any, a table for target reliability index kind of thing for the CFA pile design?
Not really. Australian piling standard AS2159 provides a bit of guideline on design, but generally speaking, in my experience, I would be very careful with end bearing resistance of CFA piles. So with soft toes, but normally it's the same design as for a board pile. And yeah, just the base, the assessment, the strength of the base is always a challenge. But normally the whole design is done in a similar way than for a concrete board pile. The principles are the same. And the risk-based approach may allow you to have better construction observation, for example. And you may achieve a slightly higher score if the contractor does it.
Okay. Okay, that's good. Yeah. So thank you, Dr. Martin, once again for delivering such a nice lecture on various construction techniques and global practices of CFA piles. Thank you.
Thank you, my pleasure. Thanks to Dr. Mitra, and thanks again to DFI India and the Kolkata chapter in particular. It has been an honor and a real pleasure to be here. Thank you.
Okay, so over to you, Pranav.
Yeah. Thank you so much, Dr. Martin and Dr. Mehta, for presentation and coordination of the session. Now we move on to the next technical talk. For this, I welcome Dr. Swagata Bisoi, Assistant Professor at Meghnad Saha Institute of Technology, to moderate this session and invite the speakers.
Okay, so thank you, Mr. Pranav. So now next presentation is on ground improvement technique by controlled modulus columns. The speakers are Mr. Ian White, Business Unit Manager, Menard, Middle East. Ian White joined Menard, Middle East in April 2019 and is currently working as Business Unit Manager for India and Central Asia for January 2024. He is responsible for the overall business in specific developing country. He is currently operating in India, Sri Lanka, Georgia, Iraq, and Pakistan. He has more than 35 years of professional experience. Before Menard, he has worked in Bussey Soletons Limited, Volker Brooks, etc. He got his Bachelor of Engineering in Civil Engineering from University of Strathclyde, Glasgow, United Kingdom in 1990. And next speaker is Mr. Prathmesh Wani, Geotech Engineer, Menard, Middle East. Mr. Prathmesh Wani is working as a geotechnical engineer or design engineer in Menard, Middle East, Dubai, UAE. He is leading the design of ground improvement techniques, including stone column, prefabricated vertical drains, dynamic replacement, rigid inclusions, dynamic compaction, and rapid impact compaction, etc. He has done his master's in geotechnical engineering in Savitribai Phule University of Pune in 2018. So I would like to request Mr. Ian White and Mr. Prathmesh Wani to start your presentation. Thank you.
Thank you, ma'am. Excellent. Thank you. Good morning, good afternoon, good evening, wherever you are. Everyone, thank you, ma'am, for the introduction. Very kind words. Thank you. I'd like to extend a big thank you also to the whole of DFI India organization for everything that you're doing for our industry. It really is excellent. As part of Menard, it's an honor and a privilege to be asked here today to join the workshop and to speak. But firstly, I'd like to extend my best wishes to our regional technical and design manager, Bedros Avakian, who was due to speak today, but he's had to attend a family emergency and sadly cannot be with us. But we wish them a speedy recovery. So instead, you have me. I've got an extensive operational plant management experience across all foundation and soil improvement techniques, expanding, as we just said there, over 35 years. I've been with the group for over 30 years and have been based in Dubai, Menard, Middle East for almost 5 years, 5 years next week, actually. And actually, from the start of this year, I'm very proud to have taken over the business operations to develop and grow the company in India. So it's great to be involved. It's been a lifelong ambition to come to India and be part of India, and I'm loving every minute of it. So excellent. Joining me today to take us through the technical section of our presentation is Prathmesh. Wani. He's a very talented senior design engineer. Although only with us a few years, he's already recognized as a leading geotechnical engineer within our company and is running our technical department in India, fully supported by Bedros and the team in Dubai, and also our extended technical team in France. So on that note, thank you again for the invitation. So I'm going to just take you through a very, very brief, quick introduction of the company, Menard. So Menard is part of the Vinci Group. You may have heard of the Vinci Group worldwide, massive organization. You can see there on the left. We are actually through Vinci Construction, and we are part of the Solitonge-Fresnay Group. So on the right-hand side, you can see the Solitonge-Fresnay companies. I'm sure you've heard of all of those. They are all operating or have operated in India. And Menard is just a part of these companies. We have three common principal businesses as part of Menard, which is soil improvement, soil investigation, and soil remediation. So Solitonge Bashi take care of all the piling, all the foundations, diaphragm walls, all the other foundation techniques, and Menard take care of the soil improvement techniques. We turn over globally around 700 million. We've got 6,000 projects worldwide, 3,000 employees, and operating in 80 countries. We have a diverse portfolio, so you can see here on the screen, we operate in all the soil improvement techniques, from vertical drains, stone columns, the compaction techniques of vibro compaction, dynamic replacement, dynamic compaction, and the rapid impact compaction. At the moment, operating in India with several of these, with the PVD, the stone column, and just about to introduce, hopefully, the CMC, which is what we're here to talk about today. Active across all sectors of all industries. If the ground is right for soil improvement, we need to be there, we want to be there. And as the introduction there, we're operating from the Middle East. We're based out of Dubai, but we're operating across the whole of the UAE, Oman, Qatar, Kuwait, Saudi, Egypt, and I'm particularly looking after Iraq, Georgia, Egypt, and now India, and also Sri Lanka. So we've got a massive resources that makes up our whole company, and we're looking forward to building and developing the business expansion in India. So on that note, I'd like to hand over to Prathmesh, and he'll take you through the technical presentation.
Thank you, Ian. Thank you for briefing about Menard. Thank you, Dr. Swagata, for my introduction. Thank you, DFI. We'll start with my presentation about the CMCs. So first thing is the ground improvement. So ground improvement problems. So why do we need ground improvement? So as we know that the basic reasons to treat poor soil, and against the bearing capacity, to achieve the targeted settlement, and to mitigate the liquefaction. So this is the example of what settlement has occurred. So we can see the example of Mexico Cathedral. So what happened in Cathedral, due to the weight of Cathedral, the soil settles, and we could see that the soil has been settled and the pavement is up and the Cathedral is down. We could see in the differential settlement as well in that photo. So this is one more example from a school from France. So the primary focus for this particular school building was on school building. So the school building were executed with deep foundation. So what happened after 5 years? So after 5 years, what happened? The surrounding soil, the surrounding ground of the school building settled down. This is due to the negligence, due to the ignorance of the weight of reclaimed field, which due to that weight, the natural clays around the building settled down. What comes after settlement? So it's bearing capacity. So we could see that most of the embankments does fail. They happens to fail in base failure due to the weak stratum below this embankment. This is an example of one of the embankment failure. What we could see that the top of the embankment settles down, and we could see that base failure has happened, and we could see a heave at the toe. This is due to the weak soil beneath the toe of this embankment. This is then what comes, it's liquefaction. So we could see that in the picture how the road and this building has sunk down due to the liquefaction settlement and the seismic activity. So when we think about the poor soil, what first comes to our mind is to replace it, to construct, to execute deep foundations, to allow some additional settlements and impart structures, or else we can do ground improvement. With ground improvement, what we can do, we can cut down the cost, save time, and avoid any other measures like I explained. So we have a different kind of range of techniques. So basically, if we have very soft clay, peat soil, or maybe soft soil, so we can do the consolidation. If we have sandy kind of soil, in that case we do the compaction techniques like it's mentioned in the figure. If we have both kind of soil, in that case we usually do inclusions. When we put down the inclusions, when we install the inclusions, what happens? The soil becomes a composite soil. When we do the consolidation or we do the compaction, the soil densifies and it creates a homogeneous soil. So today we will be focusing on CMCs, what the CMCs are. So we will jump into CMCs. So CMCs are a ground improvement method where inclusions are made up of rigid material such as concrete or mortar to achieve bearing capacity and reduce settlement. CMCs were invented in 1994 by Menard entity. So CMCs, what we can say, CMCs are typically a unreinforced vertical element that are stiffer than the surrounding soil, and this stiffer material, CMCs are applicable in all kind of soil. So this is a chart of how we have improved. So since the invention of CMCs, the number of projects has increased exponentially, with the current increase in the number of the projects standing at approximately 1,000 projects per year worldwide. And we have, till date, we have completed more than 10,000 CMC projects worldwide. So the CMCs, so where the CMCs are applicable? CMCs are applicable in all kind of soil, even if it is a soft soil, even if it is a loose soil. CMCs can carry a very high load of almost 450 kPa and achieve the stringent settlements compared to other inclusion techniques. The CMCs can execute at very close to sensitive structures. In the bottom figure, we could see that the CMCs are executed very close to the structures because of the technique. There is no vibrations and no spoils at the surface. So how much treatment we can do? So the treatment characteristics. So CMCs can be done from 2 meters to 50 meters with a diameter range of 250 to 500 mm. The replacement ratio can be kept in 1 to 9%. Material should be concrete or mortar in the range of uses of 8 to 30 mpm. In this table, we could see the anchoring, the requirement of anchors, which I will explain in the further slide. So how does the CMCs work? So CMCs are generally the load from any structure distributed on the LTP between the CMCs and the surrounding soil. So in CMCs, how it works. So your load comes on the load transfer platform and it creates an arcing effect, and it distributes the load over the CMCs and the in between soil of two CMCs. Generally, CMCs take these loads and then it transmit into the anchoring layer, like we can see in the figure here. So we could generally compare here about the CMCs with pile. So pile generally transmitted loads into the bedrock, and CMCs can transmit it load into some dense layer. So for this case, for the CMCs, the degree of improvement depends on some parameters such as the thickness of LTP. So how thick LTP you are placing, then the spacing of CMCs, the replacement ratio, how tighter the CMCs the spacing would be, and how wider the spacing would be. Then the anchoring layer. So it also depends on the anchor. So the thickness of thickness of the CMCs coming into the anchor layer. If you have bigger anchor, in that case your capacity of the CMCs increases, and the capacity of column. So in terms of capacity of column, if you have bigger diameter CMCs, you will have more capacity. If you have a good more strength of concrete, in that case you will have more strength. This is the general comparison between piles and CMC. This is a warehouse example. So in such case, what we have in piles, what we have a slab. Below that we have a pile cap, and then we have piles. So in this case, what happens when you put a loading over the piles, and when you put a loading over the CMCs? When you put a loading over piles, the load from the structure is transmitted to the pile cap, and then the pile cap transmit the load into the CMCs. So generally, the 100% of load comes into the pile. In case of CMC, what happens when you apply a load over the LTP? So it transfers, it diversifies the load in between the CMCs and in between the soil of the CMCs. So in general, we could say that the 50 to 95% of load comes on the CMCs, and remaining 5 to 50% of load goes on the surrounding soil in between of the CMCs. So this is the general behavior of CMCs, like I explained before. So it creates an arc, and it transmits the load in between CMCs and the softer soil. So what happens when you put a loading over the CMCs? So when you put a load over CMCs, what happens? The load is then initially what happens, because you're not only applying the load over the CMCs, the 100% load is not taken by the CMCs. Some load is taken by the surrounding soil. What happens? The soil settles. The soil starts settling, and up to a certain point, the soil is settling more than the CMCs. Beyond one point, the CMCs start settling more and the soil settles less. In this point is called as neutral point. So what happens below the neutral point? You get a positive friction as shown in the figure. Above this neutral point, what happens? You get a negative skin friction due to the soil taking no load, and it's transmitting the load, and it's behaving as a negative friction. So the advantages of CMCs. CMCs are very cost effective compared to the piles and stone columns. Yes, stone columns as well, because of the rigidity of the CMCs, you require lesser, and the load carrying capacity of CMCs, you required lesser number of CMCs. You can wider your spacing, and you can reduce the number of CMC columns, and your quantity is less. So in that case, you can reduce the cost. Yes, CMCs are very cost effective compared to pile and stone columns, and are successfully executed all over the world and accepted by the consultants and authority. So CMCs are cost it reduces the cost, like I said, compared to other techniques. It is very fast in execution. It's comparatively fast, which my colleague Ian will explain you in the execution section. Vibration, as I have shown you the figure, you can execute the CMC very close to a very sensitive structure, sir, and you will have no vibrations and no spoil in the surface. Yeah, applications of CMC, we have applied CMCs on the warehouse project in Logos in Australia. Oil and gas, we have used this in this sector in Majnoon, Iraq. We have installed the CMCs in Majnoon, Iraq for the tanks. We have used CMCs under embankment and MSC wall and in South Ring Road, Poland. We have used CMCs under wind farm in Fantele, Romania. Yes, in power sector as well, we have used CMCs in Yanbu power plant, Saudi. And we have done a lot of residential projects in Abu Dhabi, in Emirati housing and UAE area. So I will hand over my next part about the CMC execution to my senior, Mr. Ian.
Thank you, Prathmesh. Excellent, very good. Thank you. Yes, so CMC, I would like to first just thank Dr. Martin for explaining CFA, CMC. It was a great lead into our very short, just a few slides on execution. We wanted to keep this more technical focused, which Prathmesh has gone through, but as we know, CMC, controlled modulus column or rigid inclusions, is through displacement. I think we need to go to the next slide, Prathmesh. Prathmesh, can you just go to the next slide? Thank you. Yes. Thank you. So here you can see it's a typical auger, and maybe you saw from the very short animation that we don't have the full CFA extension. It's a short tool, CMC displacement tool. Again, it's hollow stem. What sits above that is a circular smooth hollow stem Kelly. It's not an interlocking Kelly. And basically, from the Kelly, it connects to this tool. This tool we've designed over the years. In fact, I was actually involved in the first design of screw saw piles in the UK with Bashi Soliton. So it's close to my heart to come back to do displacement piling towards the end of my career. We can do 250 to 500 millimeter diameter. Our optimum diameter here for the Middle East and most probably India is 350, 400 millimeter diameter. We've got no surface spoil, so there's no spoil coming out. Everything is displaced, retained. There's a short spoil coming at the top, but you don't have to have the spoil removal. We've got a short video here just to show you from Menard in Spain. It just shows you the execution of displacement piling. It's the same setup, same piling rig, same concrete pump, concrete lines. Everything is the same as CFA piling. So you can see there the tool going into the ground. So the tool's there, and then you can see just above there the smooth circular Kelly, which is not an interlocking Kelly, and it's not the extended CFA flights to the top. So the tool is penetrating right down to depth, so it's working in the loose soils. And as I say, the concrete needs to be the same. It's very similar to CFA. There's no real difference. The only difference is there's no cage installation, which means that everything is a lot quicker. The process is quicker. You're just moving from this point to the next point. So I think we can go to the next slide, Prathmesh. So average production is quite high compared to the likes of stone columns. It's much higher, and I think that's what we're comparing it to here. And this is the market that we are targeting in India, and it's the same that we've done as explained with Prathmesh in the Middle East. We've taken over a huge market in the Middle East with our CMC piling, replacing the stone columns. Low strength concrete, and again, similar to CFA as explained by Dr. Martin, 5 millimeter or 10 millimeter is better for the flow, and a slump of 180 to 200. We've developed Menard's Omnibox system, which is our data logging, which we're recording depth, torque, drilling speed, column diameter, and also speed of extraction to make sure that we construct, execute the optimum column. Some of you might be familiar with Jean Lutz. Yes, we do use Jean Lutz as well, and we have Jean Lutz. But Omnibox is our own in-house development that we're now using across the world. Testing, load test, plate load test, zone load test is part of the testing of CMC and the specification for CMC. Next slide, Prathmesh. So finally, it's just, you can see there, this is excavated. What I want to point out is that this was a lower cutoff. We can do lower cutoffs. It depends on the water table because there's no cage installation there. We can do the lower cutoffs, but this is just excavated here in the Middle East. You can see that we can keep some low, we've kept some higher, but this is just a typical, and that's your sort of typical spacing of about 2.2 meter spacing. And as I say, we're focusing on 350, 400 millimeter diameter. We believe that's the optimum diameter for India, and we can compete with the stone column market. So CMC, the differences, we've got CMC traditionally, no surface spoils, as I mentioned, improved friction between the soil and column, improved end bearing, and it is a cheaper option. It's a quicker solution. However, in some cases, CFA extraction method is used where very soft soils, where displacement of the soil can affect adjacent CMC existing utilities. Soil is prone to excessive heaving. We had a project up in Yambo, as described there by Prathmesh in Saudi Arabia, where we started with CMC and we moved to CFA. And obviously at the end there, as explained by Dr. Martin as well, presence of hard layers where displacement auger cannot penetrate, then we would revert to CFA, having the same rig, the same setup, concrete pump, everything. So that's just a very short overview of the execution, and Prathmesh will take it over and finish up the rest. Thank you, Prathmesh.
Thank you, Ian. So we will look into some case studies which we have done. So this is the one of the case studies. This is an oil and gas project. So Basra refinery from Iraq. So how much tanks we have? We have 47 tanks here from the range of diameter from 7 to 58 meter dia, and plus one LPG tank. And all these tank has different foundation types. So that I will explain in the next slide. So what we have done CMCs of 400 mm dia with a length ranging of 8.5 to 17 meters and grid spacing of 1.5 to 3 meters, 2.9 meters. Anchor length, we have different kind of soil profile here. So in some cases we have in the anchorage layer we have clay, and in some cases we have medium dense sand. So in clay we have anchor length, we have anchored of 1 meter, and in case of the medium dense sand we have anchored of 0.5 to 1 meters as per the requirement. So total number of CMCs that we have executed of around 24,000, and the linear meters was around 196,000 linear meters. So this is the general soil profile of the Basra. So we have taken an average soil profile and put in here. So what we have in the soil profile, we have the top 1.3 meter thick fill layer, and then we have a 10 meter thick of soft clay with a QC value of less than 1 MPa. Then after that, we have an anchorage layer. In this CPT chart, we could see it is medium dense sand. In some cases, we have some stiff clay. So both of them in the range of 4 meter. And after that, we have dense to very dense sand. So this is the pictorial view of how we have installed the CMCs, how we have put in the CMCs. So we have ring beam tank. Below that, we have changed the grid spacing for the ring beam tank, and below the raft, we have kept it separate to optimize the quantity. We have some tanks have earth mount type of foundations. So in that case, we have changed the pattern of our grid spacing and everything. We have LPG tanks, and for LPG tanks, we could see in the third pictures, and the fourth is of execution of CMC.
Mr. Prathmesh, it's
Yeah.
5 minutes actually. For your
Sure, ma'am, I
presentation.
will finish in 5 minutes.
Yeah.
Then this is one of the example from India. We have done one project for red mud pond. So this is the red mud aluminum. This is the red mud waste coming from aluminum. What we have here, the structure was a retaining wall of 10-meter high, and the load was around 200 kPa, and settlement needs to be restricted up to 100 mm. So we have executed CMCs here. This project belongs to in Ranchi, in Muri. This is one more project we have done for the data center in Khazna in Abu Dhabi in UAE. So what we have, the soil was Sabka, and we have installed CMCs. The CMC's dia was 350 mm and with a length of 7.2 meters, with the grid spacing again varying from 2 to 2.4 meters square. The load here was around 200 kPa for the slab on grade, and for the footings it was 150 kPa. This is one more example of project which is Dubai Creek Harbor. So what we have installed the CMCs below a MSE wall, and the MSE wall was huge and with a load of around 300 kPa. The project specs were to achieve the differential settlements and total settlements. The soil profile was very loose to very loose soil, silty sand with a depth of 14 meters. Then one more example of asphalt plant. Again, we have a tanks here, and the load of the tanks was 180 kPa. The soil was loose silty sand of almost 10 meters, and we have 2 tanks and 1 reactor here. As I mentioned before, we have done CMCs below the wind farm as well. So this is one of the example of Fantanili wind farm in Romania. So with the loading here is around 200 kPa, and we have installed here, and it was successful. Thank you. For further any inquiries, you can contact us. Thank you, ma'am. Over to you.
Yeah, thank you. There are some questions from the attendees, like what is the difference between CMC and micropiles?
The basic difference is in case of micropiles, you have reinforcement. In case of CMCs, you don't put in reinforcement. Like Ian explained, the execution case, in case of execution, you have a different setup. We have our own setup of installing, which improves the displacement. While you're executing, you displace the soil. It also improves the parameters of the surrounding soil in between of 2 CMCs.
Okay. Next question is, what will be the limiting concrete grade for CMC? Is there any limiting concrete grades for CMC, or is equal to the pile only?
Ian, can you answer this?
What will be the limiting concrete grade for CMC?
Yeah, there's no limit in grade. It depends on the specification of the project, but we're generally using low grade concrete, so it's usually around 20 Newton. But we also we're looking at low carbon concrete as well, and we're on some projects of upwards of 40 Newtons, but we've got a big drive for our big sustainability drive for our 2030 vision. So we're trying to optimize the design grade.
So next question is from Sandeep Deshpande, Renuka Consultants. Can you elaborate on loading platform? Are these designed, thickness, and what is material used for loading platform?
Generally, the load transfer platform can be in the range of 30 centimeters to 1 meter. So it depends on how, like I've explained, how much load your CMCs can take and how much load the surrounding soil can take. So you can design accordingly. Then the grade of this would be more of like coarser material. You can use gravels, or maybe in some cases you can use sand as well. But the requirement should be, the modulus should be approximately around 60 MPa.
So next question is from Engineer Kumar Mondal. How does the CMC, which is mainly load bearing element and not work as drainage media as like stone column, so can in case of ground treatment of soft compressible clay soil?
Generally, what happens in case of this, like I've explained, the working principle of the CMCs are basically CMCs take more load, and the distribution of the load on the surrounding soil is quite less. So what happens when in case of you have very soft clay, your CMCs, because your soil cannot take much load, in that case your CMCs takes almost 80 to 90% of load, and very minimum load goes on the clay. And when you anchor it, you don't anchor it in the soft clay. You start your CMC starts from one end and it goes into very stiff clay where you might have very less settlement in that anchor. So you neglect this soft clay layer. So your load transfer from here and it goes down to the stiff clay or maybe dense sand layer.
Okay. So next question is what from the Ramanathan. What would be the percent of loading sharing between soil and CMC when replacement ratio of 1% is adopted?
With replacement ratio of 1%, because you have very tighter grid in this case. So the more load will be on the CMCs, because you don't have very minimum space in between of two CMCs. In that case, your loading contribution would be on CMCs would be around 90-95%.
Okay. So again, next question is from Mr. Engineer Kumar Mondal. What are the construction material mostly used for making the LTP as laid over CMC?
So like I said, we can use coarse material like sand, maybe gravel, but the modulus should be around 60 MPa. More than 60 MPa, but 60 MPa can work.
Okay. Another question is from Janki Mule. How fast is CMC execution compared to stone column?
If we generally compare this, this production rate of stone column is somewhere around 200 linear meters to 250 linear meters. If we compare with CMCs, the production rate is quite high. It's around 400 to 500 linear meters per shift per rig. So if we compare, it's almost double.
Yeah, it depends on the soil profile, but we can get double production quite easily. Sometimes we've even had treble production with CMC compared to stone column. So it's a much quicker solution in a lot of soil conditions.
Okay. So another question is from Engineer Kumar Mondal. What are the minimum required depth of insertion of the CMC inside the underlying or in-bearing strata from the load transfer point of view?
Yeah, so it depends. It depends on the type of soil, how stiffer the material is. If we have very, if in case of sand, if you have very dense sand or dense sand, in that case you can, if you have very dense, in that case you can just anchor 0.5 meters. It's fine. If you have medium dense sand, in that case you need to anchor this CMCs in that layer. You can anchor at 1 meter, 1.5 meters, depending on the requirements. Like on the loadings, if we have a very higher load, in that case you need a bigger anchor, because as I explained it before, so you also need the positive frictions coming from the anchor layer.
Okay. So next question is from Madhuri. What kind of seismic effect could be observed in this CMC in general?
Basically, CMCs, in case of seismic events, what happens because of generally because of this CMCs are not reinforced, So if we have very lateral forces coming on the CMCs, the CMCs can carry up to a certain limit, but beyond the certain limit, they doesn't work. So it also improves liquefaction to a certain extent, but not to a like stone column. It does not improve up to that limit because of unreinforced. But in case if we have very high seismic zone, and in that case you required to do reinforced CMCs. So because your lateral load, your seismic forces coming on the CMCs are quite high, in that case you can do reinforced CMCs as well. So we have done few of the reinforced CMC in some of the projects in France.
Okay. So next question is for Fahim. How CMC can be used for taking lateral load? What is the mechanism of bending moment resistance of CMCs?
So it's the same question. I have explained it like before. So in seismic cases, in some cases it up to a certain limit it can carry the lateral load, but beyond that you need a reinforcement. You need to make it reinforced CMCs. So that's what.
Okay. So last question from Sadiq, Bangladesh Road Research Laboratory. What is the comparative cost of CMC and stone column? Example 1.5 meters center to center square pattern with 20 meter depth.
We can't compare CMCs with stone column with the same grade spacing. If you have a same loading, if I've considered you have 150 kPa loading, and if you put stone columns there, your grid spacing would be different, and with CMCs your grid spacing will be different, because your modulus of stone and modulus of concrete is completely different. You have very stiffer, very rigid material in CMCs, and you have very you can say the modulus of stones may be in the range of 60 to 90 MPa, and in case of concrete is quite high. So if we compare both, your grid spacing would not be same, and your length as well would not be same, because stone columns can be rested at a stiffer layer, but in CMCs you need to anchor CMCs in the stiffer layer. So there's a difference. But if you compare us with the same loading and with the different grid spacing, because you will require the minimum number of CMCs compared to stone columns, your cost of CMCs would be cheaper in many cases, but it depends on the type of soil as well.
Okay. So thank you, Mr. Jan and Prathmesh, for your valuable presentation. Now I would over to Pranab sir. Mr. Pranab,
Thank
please.
you, DFI.
Thank you very much. Thank you very much. It's been a pleasure. Thank you.
Thank you, Mr. Jan and Mr. Prathmesh. And thank you, Dr. Swagata, for moderating the session. Now we move to the next technical presentation. For this, I again invite Mr. Chiranjeev Sarkar, sir, Principal Engineer, Geoconsult India Private Limited, to moderate the session and introduce the speaker. Over to you, Chiranjeev, sir.
Hello, everyone. Our next presentation is on design approaches for CFA piles by Mr. Anirudhan IV. Anirudhan IV is a geotechnical consultant based in Chennai. His career is an independent consultant started in 1987 after associating with leading firm for 7 years. His major field of expertise are deep foundation, ground improvement, and geotechnical characterization. He conducted several conferences, workshops, and seminars. He is the immediate past chairman of Deep Foundation Institute of India, DFI, and he is also served as a chairman and honorary secretary for Chennai chapter of Indian Geotechnical Society. So now I would request Anirudhan sir to continue with your presentation, sir. Over to you, sir.
Yeah, thank you, Chiranjeev. Am I audible to you?
Yes, sir, you are audible, sir.
Yeah, I'll share the screen now. So I have a very simple responsibility of telling you about design approaches for continuous flight auger I thank IGS Calcutta chapter and DFI of India for giving this opportunity. When I told it is simple activity, because most of them are aware of the design of broadcast in situ piles. And in the case of CFA pile, there is no much difference, except that we try to use field-oriented approaches in designing the CFA piles, because it has a different construction procedure. So this, as explained by Mr. Martin, we have a full length continuous flight auger with hollow stump going into the ground to the required depth. Then we withdraw the auger in the same fashion as we went inside, but we pump the grout or concrete into the hole while we withdraw the auger. Then after completing the concreting, we introduce the reinforcement, and often partially. And if the pile length is smaller, we can complete insert the reinforcement for the full length. So this is the process for continuous flight auger. And the main difference between the board pile and CFA is the stabilization of the sides. In the case of board piles, we stabilize the sides by drilling fluid. And in the case of CFA piles, the side is stabilized by the soil filled between the auger blades. And the other major difference is that we introduce the reinforcement before concreting in the case of board piles, and in the case of CFA, we have to introduce the reinforcement after concreting. So these are the main major differences by which the construction procedure is significantly different between board pile and CFA piles. As far as the construction rate is concerned, the CFA piles are much faster because of the much faster advancement of the auger into the ground. And as far as the behavior of the CFA pile is concerned, we have very similar behavior like any other piles, but the behavior is more closer to broadcast in situ piles or drill shafts. But we have a better performance compared to board piles because of no drilling fluid in the construction process, and there is no much significant base disturbance. Of course, it depends upon the type of soil available at the base, and there is no chance of any hydraulic imbalance while making a borehole, because we do not make a borehole in the case of CFA piles. We have several guideline documents for design of CFA piles. As discussed by Mr. Martin, the Australian code is very conveniently used there, and we generally want to follow with whatever US has produced, and to some extent what the the UK has produced. So one of the most detailed document is by Federal Highway Authority of US, Geotechnical Engineering Circular GEC 08. And we have a auger cast in place pile manual by DFI, which is which was modified in 2016. And we also have a design and construction guideline by DFI of India based on some trials we conducted during 2019. So these documents are available for design of CFA piles, and I will briefly explain the provisions in these documents. Like any other piles, CFA also derives its capacity from side resistance as well as the base resistance. We all know that the base resistance is due to the interface between friction and adhesion along the interface of the pile shaft, and the base resistance is developed by cavity expansion around the pile base. As in the case of any other piling system, we can estimate the side resistance and base resistance separately and add together to get the complete the full capacity of the pile. So we have the common equation like the total resistance is a summing up of the side resistance and the base resistance. And the side resistance is a summation of the side resistance from different layers along the pile shaft. And the base resistance is based on the soil characteristics at the base. And for estimating side resistance, we divide the soil profile into several layers for estimating the resistance from each layer, using the side resistance from each layer and multiplying with the surface area of the shaft within that layer. So, and we sum it up to get the total side resistance. And similarly, for the unbearing resistance, we use the properties of the soil at the base, and it is a function of the unit base resistance and the area of cross section of the base. So we need a certain embedment into the bearing stratum to achieve the full base resistance. So that I will discuss in the next couple of slides. And as I said, we generally depend upon the Federal Highway circular GEC 08 for estimating the side resistance and base resistance. And these procedures are developed from the research carried out by Rees and O'Neill on several test piles. And they have developed empirical procedures for estimating the base resistance and the side resistance. Studies show that this procedure is reliable in estimating CFA pile capacities in both cohesive and cohesionless soils. For a given pile segment, the ultimate unit side resistance is a factor of undrained shear strength, SU, in the case of cohesive soils, and addition factor alpha of 0.45 to 0.55 is used in the estimations. These are based on the field experiences. And you can also see that there is an apparent limit of 115 kPa as the unit side resistance, which is equivalent to undrained shear strength of 250 kPa. So for stiffer soils, we do not increase the side resistance based on the undrained shear strength, but we limit the undrained the unit resistance as 115 kPa. And there is also a procedure from cone resistance profile in which we estimate the side resistance from the point resistance we have from the CPT or CPTU. And for example, for cone resistance of 2 MPa, we have a side resistance of 80 kPa or 0.08 MPa. And in the case of the cone resistance 5 MPa, the resistance is something like 115 kPa, which is the limit as recommended by these procedures. As you can see, in this case also, we have a limiting side resistance after we exceed certain amount of cone resistance. We cannot keep on increasing the side resistance for a higher cone resistance values. How do we estimate all these undrained shear strength for these estimations? There are different procedures. And if we have a very top quality undisturbed samples from the field, we can estimate the undrained shear strength using triaxial consolidated undrained test, preferably consolidated under pressure equal to the effective overburden pressure at the sample depth. Alternatively, we can estimate the undrained shear strength from SPT value using N60, which is the uncorrected SPTN corresponding to 60% efficiency from this expression. But again, limiting to 250 kPa of the undrained shear strength. We can also estimate the undrained shear strength from cone resistance using these expressions when we have CPT and CPTU profiles. And we estimate the undrained shear strength from standard procedures available for these test methods. Coming to the base resistance, it is also the factor of undrained shear strength. We often use the bearing capacity factor NC ranging between 6.55 to 9 for estimating the ultimate base resistance for piles resting in clay soil. And when the shear strength is smaller than 200 kPa, we try to use a reduced bearing capacity factor. When we have a smaller shear strength, we use lesser bearing capacity factor 6.55. When we have the maximum undrained shear strength, we use 9 NCS 9, which is the maximum limit for any estimation. Here also we have to have the minimum embedment length of 3D to achieve the full bearing resistance corresponding to these different NC values. But in case we have a lesser penetration or length into the bearing stratum, we have to use a reduction factor to the NC we estimated either from rigidity index or from the for higher values. So we use this reduction factor to reduce the NC factor. And there is a very conservative estimation from CPT and CPTU profile for the base resistance, which is given as about 15% of the cone resistance, which is very conservative if you compare to the procedure using the undrained shear strength. Here also we have to use the average cone resistance, the minimum between 60 length, that is 3D above the ground, and 3D below the ground. In the case of cohesionless soil, we adopt the effective stress approach for estimating the side resistance using the standard function, like friction resistance is a function of angle of shearing resistance, bearing these pressure coefficient K, and the effective stress at the mid depth of each layer we consider in the estimation. From field procedures, this parameter K into tan phi, which is a function of the earth pressure coefficient and the shearing resistance, into a one single factor called beta, which they found is dependent upon, very much dependent upon the depth of each strata. And based on the field experiments, these experiments are arrived at for estimating the Z factor, which is a combined factor of K and tan phi. For the sand layers, these are the usual expressions we use. When we have an SPTN smaller than 15, we reduce the beta factor accordingly to take care of the loose sand layer effects. And we have different expressions for gravel and gravelly sand, which is shown here. And for silty sand, we have a smaller Z factor from these expressions. So if we use these expressions, we will get a lesser unit side resistance. And for gravel and gravelly sand, we get a relatively higher side resistance. And for the base resistance, in the case of cohesionless soil, we can use either the field SPTN values under 60% energy from this expression, cone resistance as 57.5 times the N value, but limited to 4.3 MPa. Here also we have to have the average N values within this depth range, preferably minimum this depth range. Some people have recommended that for a longer depth, like 5D or 8D above the pile base. And if the soil is predominantly silty soil, we have to reduce this end bearing by 25%, and we apply a multiplication factor of 0.75 for estimating the ultimate bearing resistance. We can also estimate the base resistance using the cone resistance profile, using this expression. Again, with the averaging of the cone resistance within the depth range above and below the base of the pile. So this is the way of estimating the ultimate capacity of any CFA pile, very similar to what we use for other drill shaft and driven piles or any other type of piles. When we talk about the how these side resistance and base strengths are developed along the pile during loading of the pile. So there are several studies on instrumented piles which showed that when we apply a load at the pile tip, pile top, it is initially taken by the friction at the shallow depths. Then as and we increase the load, it keeps on developing more friction towards depth, and it starts developing very small amount of base resistance. As we keep loading the pile, we develop full skin friction and then start developing more and more base resistance. So from these experiments, we have seen that we need about 0.7% to 1.2% of the pile diameter as the pile movement for mobilizing the full skin friction, but only very limited base resistance is mobilized for this displacement. But when the displacement is more than 5% or 10%, we develop the full base resistance. So these are from the experimental, the instrumented pile testing procedures. And more, we can see more clearly from this expression, say you develop the end bearing in this rate as and we move the pile or load the pile, and it achieves certain movements. But you can see that the full amount of skin friction is developed for very small movement. And we add up these two values, we get the ultimate capacity of the pile, or at different, or the maximum capacity of the pile under each as the pile moves downward. So we arrive at the safe capacity of this CFA pile also very similar to other piles by applying a factor of safety 2 to 2.5 over the ultimate capacity. So generally in normal procedures, we apply a global factor of safety equal to 2 to 2.5. And in the case of any estimated values, in which we add both side friction and base resistance to get the ultimate capacity, then divide it by a global factor of safety 2 to 2.5. If you do a pile load test, we use a global factor of safety 2 to arrive at the safe capacity. As we have seen the response of any pile under loading, that we have seen that the most of the skin friction is developed for very small movement. We can also go for a partial factor of safety approach, in which we give a lesser factor of safety for the skin friction in the range of 1.5 to 2, 1.5 for a coarse soil and 2 for a fine grained soil, and a slightly higher factor of safety for the base resistance, which is 3 for coarse soil and 2.4 for fine grained soil. So we have to take least of these two values to arrive at the safe capacity of a pile. This is true for most type of piles, not only for CFA piles. And coming to the response to lateral loading, we can use the standard subgrade modulus approach given in IS code, or we can also go for a PY approach in the for estimating the lateral response. But if you see the IS procedure in which they have given a certain value for the modulus of subgrade variation, the coefficient of modulus variation, very low values, which is considered to be very conservative. And many studies have shown that these values are very small. It produces very small lateral resistance. We recommend to use these values for a more realistic lateral resistance for the piles, including the CFA piles. Then, as in the case of any other piles, the uplift capacity is also equal to the total side resistance. But we tend to use a slightly reduced value compared to the total compression friction. About 75 to 80% of the side resistance under compression is considered as the ultimate capacity.
Sir, we have 5 minutes left for you, sir.
Yeah, thank you. Then the recommended factor safety is about 2.75 to 3 for the estimating the safe uplift capacity. We can add the submerged unit weight of the pile also to get the gross safe uplift capacity as like 80% of the side resistance under compression load and divided by the factor safety, and adding the weight of submerged weight of the pile, we get the safe uplift capacity. When we come to a group piles, group CFA piles, here in this case also we have to apply group efficiency when the pile spacing is very small. We tend to have a full efficiency equal to 1 when the spacing is more than 6 diameters and reduced to about 2/3 or the 75% when we have the spacing is only 2.5 times the pile diameter. And we can have the group efficiency by interpolation between these spacings for other spacings. In the case of cohesive soils, we have to consider a block failure to find out the group efficiency, meaning that we have to find out the bearing capacity along the sides and from the base of this block confined by the piles to arrive at the group efficiency. In the case of uplift capacity, we have to assume the uplift capacity as the weight of the soil confined by the piles. We considered as 2/3 of the effective weight as the safe uplift capacity. This is the total weight of the soil confined by the piles. Or alternatively, half of the effective weight plus half of the resistance along the surface between the soil surface. So this is one way of estimating the safe capacity of a group under uplift load. And a typical estimation we did for our trial site where we have full silty sand layers with more than 60 to 70% silt content. And this is a typical estimation of side resistance using the beta procedure. This is the using the standard correlation for sand layers, and this is for the layer assuming the high silt content. So, and we have estimated the base resistance using the standard SPTN value and the standard expression for sand profile. And we got a base resistance of about 459 kilonewton. Estimating the total base resistance as 2000 kilonewton, 2000 plus kilonewton as the higher upper bound, and the about 1700 kilonewton as the lower bound. So when we think about the behavior, settlement response under axial load, as explained earlier, very small movement of the pile will develop full skin friction, and we need a larger displacement of the pile base for full base resistance. And the earlier one was cohesive soil. This is for a cohesionless soil. Similar performance is found for piles in cohesive soil as well as also. And based on these standard procedures, we estimated the possible load settlement response of the test piles. And this is the end bearing base resistance for different pile displacement, and this is the skin friction development. And we got a total estimated load. And we also, I also put the lower bound value from the estimation, which is about 1750. Here it is about 2000 kilonewton. And this is the response we got from the pile load test, and which is very closer to the estimated upper bound value. So which says that the procedure as proposed in FSWH is applicable to CFA pile as well. And we can follow the same procedure for estimating the safe capacities. And concluding remarks, the behavior of CFA pile is like podcast in situ pile. There is no much difference, except that there may be mild improvement in the load settlement response. And ultimate compression, uplift, and lateral capacities can be estimated as in the case of podcast in situ piles. The estimation often results conservative values, and scope for improvising the estimation based on experience in Indian soil conditions. And these are some of the selected references. Thank you, Chiram.
Yeah. Thank you very much, sir, for your wonderful presentation. So now we will move to the question answer session. Sir, we have one question that what is the cavity expansion theory in this case? The question is from Sadiq, Bangladesh.
Yeah,
What is the
it's
cavity
very,
expansion theory?
yeah, we need it's a very huge topic. Cavity expansion is when we try to apply a load in a confined space, we try to expand the soil in a and which produce resistance to that in a simpler terms. So it cannot be explained in very simple terms.
Okay. Next question is, how effective is the CFA pile in taking uplift load?
It is same as any other pile. We have seen from the test also, we got more or less same as the positive skin friction as uplift load from our trial test. So even though we apply certain slightly higher factor of safety, but we get the same side resistance from the under compressive load.
Next question from Pooja Desai. Sir, how we can get the capacity using Plaxis for model pile? Can we go with the plate element?
No, we cannot get it from plate element because plate element we generally is applied in a 2D case. So if you have 3D, probably we can estimate, but we have to put all the interaction parameters. A lot of input is required to decide on how it behaves. You can use volume element for better results because we are concerned about the capacity, not any bending actions in the pile. So.
Okay, sir, one more question from Rahul Kumar. Can we use CFA pile in port project?
So we have the issues of lateral capacity because of the reinforcement being not pushed into the soil in the concrete fully. If you are able to push the reinforcement to full length, it is possible. But the CFA pile is possible only in any ground, not in any offshore conditions.
Next question from Arun Karthik. Is there any limiting depth of penetration for drilling?
Yeah, it is all discussed by Mr. Martin. There is usually we limit to 18 to 20 meters if you want to push the reinforcement for the full length. And the worldwide there is experience of making CFA piles to very large depth, especially when the diameter is large, so to 40 to 50 meters. So it all depends on the soil and the capability of the machine we use. and of course the applications. If you need to have large the reinforcement for the full length and heavy reinforcement, then the depth is limited.
I think you have answered all the question. Thank you again, sir, for your
Thank you.
amazing presentation. And now we will move forward. So I will hand over to this session again to Mr. Pranav. Pranav, over to you.
Thank you so much. Thank you, Anirudhan sir, and thank you, Chiranjeev sir, for moderating the session. And now the final technical presentation for the program. For this, I call Dr. Supriya Paul, who is Associate Professor at NIT Durgapur, to moderate the session and give introduction to the speaker. Dr. Paul.
Thank you very much, Mr. Pranav. So, very good afternoon to all the participants. So, our next speaker is Dr. Sunil Basarkar. He is Vice President, Avakian Infrastructure Limited. So, the topic of his presentation is CFA piles, methodology, DFI trials, suitability and application in Indian conditions. So, I'm happy to introduce Dr. Basarkar here. Dr. Basarkar is the Vice President of Design and Geotechnical Head at Avakian Infrastructure Limited. He has a total experience of about 20 years in the field and 16-year association with academia in the area of geotechnical engineering. He is co-convener DIS CD 43 panel T20 for draft CFA filing guidelines and chair of CFA Pile Technical Committee, DFI of India. Dr. Basarkar is also a fellow of Institute of Engineers India, Indian Geotechnical Society, Institute of Bridge Engineering. Dr. Basarkar has published more than 50 papers in peer-reviewed national, international journals and conferences. He is the Vice Chair of DFI India. So I would like to request Dr. Basarkar to deliver his presentation. Over to Dr. Basarkar.
Thank you very much, Dr. Supriya Paul. Am I audible to the audience?
Yes, sir. You are audible.
Thank you very much. I'll switch off my video for a while and start sharing the screen. Is the screen visible?
Yes, sir. Please make it in full screen, sir.
Yeah, thank you very much. So this is the presentation I intend to make, which is on the CFA piles. What are the Deep Foundation Institute's trials were undertaken? What is the suitability and its application for the Indian conditions? Well, there is a need for CFA pile in order to accelerate the India's piling ambitions in terms of the progress. So we need a high productivity, we need a safer and a well-quality pile when compared to the board cast in situ pile, which if it is neglected in terms of quality, then the board cast in situ can be a problematic pile. So CFA pile can ensure a higher productivity than the board pile, and particularly in the load range of 50 to 500 metric ton. Typically, the diameter can range from 450 to even as high as 1200 diameter. But at the moment, India needs to focus on the pile diameter between 450 to 750 and in a lower range between 50 and 150 metric ton. Conventional rigs can be modified to accommodate the CFA piling. So there are a lot of advantages, as the Ernst pile speakers, they have actually highlighted that particularly the fast progress a good quality, a good control are the possible advantages of CFA pile. Now, in India, if you come to the scenario, their execution has just commenced in India. There are concerns and apprehensions that cage has to be pushed into the wet concrete. Well, I need to assure that with a proper management, this concern is eliminated. Concrete supply logistics is not smooth in India, particularly in urban scenario. But yes, if you are assured of logistics, then the CFA pile can be executed even in urban as well as in the remote scenario. There is no code or guideline or standards for CFA pile in India. Well, I wish to assure that soon a guideline is going to emerge from India. How do you apply it to the soil types? As our speakers earlier had informed, that clay, silt, sand, gravel, soft rock, and even limestone type of weak rock can be amenable to CFA piles. Partially weathered rock with a modification of the tip of the auger, they can be modified and we can have a CFA pile. But yes, if it is a high bouldery rock, a refusal beyond, let us say, SPT of 75, the CFA pile can be a challenge. In rock, CFA pile should not be executed. If you see the Indian soil map, we see that most of the alluvial zones are very much suitable and favorable for CFA pile. Bulk of Indian map, if you see, I'll say close to about 30 to 50% of Indian soils, they are amenable to the CFA type of pile. So this portion of India, the northeast portions of India, much of our coastal regions, much of our part of Gujarat, part of North MP, Rajasthan, Delhi, and all alluvial area, they'll come under a suitable zone for CFA piles. Now, what are the equipments that can be suitable for Indian conditions? We need to be very particular that whatever equipments or the modifications of the tool are required, they have to be very suitable and economical and adaptable in Indian region. So with that in mind, it is very much possible that hydraulic rig or the crawler mounted cranes can be actually converted to fit the continuous flight augers. The torque requirement will be typically from 28 to 120 kilonewton meter for crane mounted rigs and from 90 to even 400 kilonewton meter for hydraulic rigs. You'll require a certain crowd pressure to push the auger into the strong soil. Typically, the auger, the crowd pressure will be less in the crane mounted rig, up to the maximum 45 kilonewton, but it will be higher for a hydraulic rig, going up to even 270 kilonewton. You'll require certain modifications. And with modifications, yes, definitely you can implement the CFA piles. So this is the crane mounted CFA pile rig. You need to have a leader, you need to have an actual adapter, the gearbox that can be attached to the leader, and then this continuous flight and the tool at the bottom that can serve as a CFA pile. The conventional hydraulic rig can be modified and it can be included to have a long flight with a top head, the cat head, and the modified bit at the bottom. They can serve to have a continuous flight of even up to 20 meters long. How do you plan for the equipment in CFA pile? Particularly when I speak considering the Indian scenario in mind. So here, this is a typical hydraulic rig which is fitted with the CFA pile flight. So what you'll require is a CFA with an attached drilling bit. You'll require sleeves to connect to the hydraulic rig. You'll require a rotary head and the cat head to connect it at the top. The auger guide that will ensure a verticality of the auger in question, and some of the sensors and data monitoring that can be actually attached to the panel of the rig. So this AMU, or what we call a automatic measuring device, can assist us to monitor the progress of the pile and to assure the quality of the pile that is going to come and going to take up the load. So over here, you will require a auger head that can connect to the rig and it can connect to the flight in question. Then you'll require some bottom plug so that the operations of the concrete can be facilitated. This is a typical plug, that is a flat plate bottom plug that we had used in one of our trials of DFI in the North India. Now you have to continuously remove the soil from the auger, which means you need to have a mechanical cleaner. The faster the operations of removal, the better it is for the housekeeping of the site. Then you'll require some form of a concrete pump and the pipes to deliver the concrete to the top of the CFA pipe. So typically you'll find that the maximum concrete output should be between 42 or 73, depending on which side of the movement the pump is having. The concrete pressure will typically vary to the maximum of 108 bars. You need to have a hopper capacity of about approximately 400 liters of capacity. The diameter of this supply pipe can be typically of any other concrete supply pipe, which is about 125 mm. Then you'll require a crane, typically 55 to even 70 ton capacity, that is going to lift up the cage and it is going to lower into the wet concrete. You have to remove the spoils, for which you'll require an excavator. And this is a typical excavator, which is going to remove it and load it into the truck, and the truck will dispatch the spoil out of the site. Normally, a cage has to be designed to go completely into the wet concrete by its own weight. So any form of concrete mix design should ensure that all the pile should be capable of being inserted into the concrete pile on its own weight. If it doesn't happen, at times the cage gets stuck. You need to have a provision, emergency provision of a ring vibrator underneath. With the ring vibrator, you can provide a vibrator impulses and you can push the cage into the wet concrete. Then you require a batching plant. A batching plant requirement should be typically 45 cubic meter per hour. So this is well decided by the plant engineer, who is well versed with the requirement of the pipe. So all this will depend on how many piles are under activity and what is the diameter of the pile, the length of the pile, and the capacity requirement. This will decide the batching plant capacity. The sturdiness of the cage is very essential component. You'll require certain area earmarked for fabricating of the cage. Typically, you'll find that the longitudinal reinforcement diameter will vary from 20 to about even 32 mm diameter. Lateral reinforcement, owing to the sturdiness requirement, will have to be about 10 to 12 mm diameter. And stiffness can be in form of a flat plate, or it can be in form of rebars of about 10 to 16 mm diameter. 16 mm diameter will be a preferred stiffener requirement. There can be circular synthetic cover blocks, or it can be a mortar cover blocks. The one that is shown over here is a synthetic cover blocks. It will be left up to the designers, executioners to decide what will be the type of the cover blocks required. Now you can go in for some kind of instrumentation for the CFA pile cage. The cage will be four-hand. It will be fitted with the instruments. We can have sensors. We can have data monitors with a data logger at the top. It can assist us in knowing what is the load transfer behavior of the CFA pile. QC requirement of a CFA pile is the most and the foremost. The typical factors that has to go into consideration is the appropriate mix design of the concrete or the grout we are using. Design of the steel cage should be for its sturdiness. The cage should be sturdy enough to be pushed into the wet concrete. There are other quality issues, quality requirement, which will be required in terms of the auger advancement and its withdrawal with the simultaneous concreting or grouting from the pile board. If we speak of the concrete or the grout mix design, the workability of this concrete is very, very important, which means in order to have a good workability, you need to have a fine aggregate, you'll have to have a combination of the additives, you'll have to have coarse aggregates restricted to about 10 mm or let us say a ½ inch of the size of the aggregates. So this will allow more focus on the workable pile. You need to perform the workability test, which means the inverted Abrams cone test will be important. You measure the workability by measuring the flow value. The flow value typically in Indian tropical climate, it should vary between 760 to about 800 to 890 mm. The hotter the region, the more workable or the more flow value you will be requiring. And this flow value will have to be maintained for at least 4 hours. And that means your concrete mix design should be able to prove the retention of the workability in the time of execution. As I told, sturdiness have to be an important parameter, which means it will be important to have more number of bars of lesser diameter than having a lesser diameter, lesser spacing, or the lesser diameter bar with a more spacing. This factor has to be borne in mind. The ring spacings have to be as close as possible, preferably about 150 mm, 6-inch center to center. The idea is to have a sturdy and more stiffer cage that will impart a sturdiness to lower it into the wet concrete. This is the AME unit, which means all the parameters of the pile during execution will be monitored and recorded in data logging form. You'll be getting the pile profile throughout the depth. You'll be requiring the concrete volume that is consumed. What is the grout factor? It is nothing but a ratio of the actual versus the theoretical concrete that is consumed. The drilling rate, auger lift rate, the concrete pressure, the auger rotating speed at the top, they are recorded by automatic monitoring devices. Quality assurance test. These are typical tests that can be applied, which are likely to be used for any other piles. You can conduct the static load test for the compression, for the tension, and for the lateral load test. There can be a high strength dynamic test with a setup typical for any other piles. You need to have an integrity load test performed. You can have a low strength dynamic test, or you can perform either the thermal integrity profiling test, which is a recent addition of technology in Indian scenario, or you can even have a cross-hole sonic logging. With thermal integrity profiling, you can get the idea of not only the pile integrity during the starting stage, but also throughout the life of the pile, as long as the sensors and the data logger are active. So that means the curing of the concrete and how and at what rate the gain strength is attained, that can be also recorded by thermal integrity profiling test. So it has much advantage of the data compared to the cross-hole sonic logging. Now, this is a very interesting technological trials we have undertaken at Hisar's location at Haryana state. This was an initiative of DFI of India, and it was an elaborate committee that was formed to see that this technology initiative is demonstrated in presence of all the stakeholders in India. We had an elaborate committee. Thanks to this committee members, thanks to the DFI USA team, and thanks to the DFI office team, that we could handle this problem in a very coordinated manner. There was a generous support to this mission. The budget of this mission was close to about 80 lakhs, and we received much of the amount in form of a donation, and there were a lot of charitable and in-kind support we had received from several of these organizations. My humble thanks to all these organizations and those people who were involved with this mission. Coming to the location, this is New Delhi, and close to about 250 kilometers, 210 kilometers is the town of Hisar. More particularly, we had conducted at a Gorakhpur location at Haryana state, in which we had been allocated a trial patch of NPCIL, that is Nuclear Power Corporation of India's land, for conducting the trials. If you see the profile of the ground in this location, you'll find that it is typically a silty, sandy silt location for, let us say, top 15 to 20 meters, followed by sandy silt with a higher values of N below that. Typically, it is a cohesionless material with a water table as high as about 2 meters below the ground. You'll find that N values, they vary from 8 to 20 for the top 15 meters, and thereafter, it is going up to even refusal to the bottom, let us say 25 meters. So we have decided to have about 6 CFA piles of 600 diameter and 11 meter. 11 meter was restricted because of the choice and availability of the CFA auger with us. It had a length of 15 meters with us. We could go with about 11 meters only because we wanted a pure CFA pile without any additional tube, extra tube or follow-on tube for the CFA pile. So which means 11 meter of piles were a purely conducted piles with continuous flight. So these were the 6 piles. They were the actual piles they were tested. In addition, we had conducted 2 pre-trial piles just to have an idea of the experience of the piling with the CFA tools, with the CFA rigs, and the CFA flight. So these 6 CFA piles, we have conducted 2 vertical tests, 2 pull-out tests, and 2 lateral tests. And all piles were subjected to true strain dynamic testing to check its integrity. So this was a typical reinforcement cage that was used. We had used a 20 mm bar as a main steel and 10 mm bar for the spirals, and they were spaced at 150 mm center to center. There were spacers which were in form of a flat MS flats, and they were spaced at 1 meter center to center. Overall, it had provided enough sturdiness to put and insert the cage into the wet concrete. We had even installed 3 levels of instrumentation into this reinforced pile so that we could monitor the performance of the pile from top to bottom and understand the load transfer behavior. So this were the locations, the coordinates of the pile, the piling sequence. We had undertaken trial piles, which we call probe piles. And then P6, P1, P2, P5, P4, P3 were the sequences of the pile undertaken. So with that, from 27th of May 2019 to 30th of May 2019, we were able to execute all the 6+2, that is 8 piles together. And it was a very encouraging result because a learning experience of PTP1 had been translated into successful execution of the 6 piles in picture. So these are the piles executed, and the load test we performed during November 2019, that is about 5 months from the date of execution. There was a pull-out load test, 70-ton diameter, 70 ton of load applied. For vertical compression, 170-ton load applied. And for lateral, it was subjected to 12 metric ton. Some of the snapshots of the DFI trials. This is a panoramic view. You can see the rig fitted with the continuous flight. This is the concrete pump. It is pumping concrete to the top of the CFA auger through these tubes. Then there is a 55-ton hydraulic crane available, ready to lift up the cage and insert it into the wet concrete. This is a cage fabrication in progress. So you can see that this concrete tube is extending to the top of the flight, and inside the flight, you can see there'll be a particular hole that will transfer the concrete to the bottom of the tube. This is the actual slump measurement in progress, and you can see we had intentionally poured the concrete on the surface, and you can see the flowability of the concrete, which is an essential requirement. As soon as the pile is concreted, then the fact remains of inserting the cage into the wet concrete. The cage has to be inserted essentially by its own weight. And that will require a very essential requirement. That is, what is the flowability of the concrete we have used for the piling. So this is what the concrete is. And after the insertion of full cage, what it looks like. You can see that it is still in fluid condition, which means after a couple of hours, the hardening of the concrete is going to take place. Couple of cages were there, which required to be pushed by some manual means. We had this auger bucket in which the excavator bucket in which we had used to push the cage into the wet concrete. We had performed the load test on the CFA piles. This is the vertical load test performed on P2 and P3. 170 was the test load, whereas we have applied 179.87 of the maximum ton. So here we could have about 12 mm of the
Sorry to interrupt you, sir. Dr. Basakar, sir. Sorry to
I'll wind up.
We have only 5 minutes.
I'll wind up in 5 minutes. Thank
please. Yeah, okay, thank you.
So we could have about 12 mm of displacement, whereas net displacement were 8 mm. So with that, second pile also was performing almost similar to the first pile. You can see the load settlement curve in which we can see that two piles are replicating the performance exactly in the same way. There is a lot of good capacity indications of this pile, which indicates that the quality is identical for the two piles and the capacity obtained are identical for the two piles. Same thing goes for the lateral load test also. The two piles are replicating the capacities in exact terms, which indicates that quality of the piles are consistent. Same thing we had actually obtained close to 70 ton of the capacity and probably more of the uplift capacity for this pile. The advantage of the CFA pile is very, very apparent. In this, the quality are identical and there is a replication of the piles capacity in all facets. So this is the lessons. The demonstration involving the designs had been taken place. It was a very successful demonstration with all the stakeholders. The testing of the piles were conducted and we actually authenticated the design requirements. And we found that the capacities can have an upward revision between 15 to 20% than what we do by conventional pile designs. We had come up with a lot of documents based on our experiences of this technology initiative. We have a DFI document for design and construction of the CFA piles. We have a CFA pile trial installation report in which what are the experiences of our pile installation, what are the quality norms we had taken, what are the test of quality we had performed. That is exactly brought out in this document. Then there is a load test manual, load test report we had prepared that contains the details of the 6 load tests we have performed. That is 3 load tests, including the high strength dynamic, the load strength dynamic test also we had performed. And there is an instrumentation record in this document. You'll find that a subcommittee is formed by BIS, that is Bureau of Indian Standards, and already a subcommittee is undertaking preparation of a draft manual, draft guideline for CFA piles. Much about 2 years has passed since the formation of this committee. And this is the subcommittee members. You'll find there are 10 in all, and they cover the consultants, the contractors, the academicians, and the client representatives. So we have all stakeholders that will form the part of this subcommittee. This is part of the CD43 group, and slowly the draft guideline is almost ready. It will be passed on to the main body of the BIS in about a month's time, and we can see the light of the day, a code emerging for CFA piles in another 6 months or so. So this is a CFA piling committee of DFI of India, and thanks to the DFI for giving me an opportunity to chair this committee and perform a series of technology implementations trials and see that CFA piles can see the light of the day in India. So now the efforts are nearing fruition, and CFA pile design and construction is going to see the IS code in line of 2911 series. The CFA pile will continue to put up its efforts to facilitate implementation of this pile in future Indian projects. 2 CFA piles, for your information, has already been executed in the state of Assam and Gujarat, and we are going to see much of this activity coming up in the near future. Now, what can the stakeholders do? As a client, you can strive to include the CFA piles in the tenders. You can prepare a specifications for the CFA piles and include it in the tender documents. You can encourage use of CFA piles for non-tendered location in which a tender is not existing. As an engineering contractor, you can strive to execute the CFA piles at the site where the contract conditions permit. You can use CFA pile for normal or the minor civil structures. You can encourage use of the piles with the available equipments of CFA piling. As an equipment manufacturer, you can facilitate availability of the equipment on economical mode to start with. You can even have a rental basis, supply it to the contractors so that pile can be executed where the numbers are less. The CFA equipment under special conditions of low headrooms or the access issues can be supplied by the equipment manufacturers. As academicians, designers, and valuable stakeholders, you can facilitate use of CFA piles by your own means. You can promote and disseminate the merits of CFA piles. You can carry out the research for the quality and capacity enhancement of the CFA pile. Well, this is the team that had been installed, and they were at the site for implementing the CFA trials. They were coming from at least 4 different countries to execute, and this committee, including all the stakeholders, they were close to about 30 numbers. They were assembled at the site to see that the CFA trials were successful. Thanks a lot to IGS chapter, DFI of India for this symbiosis, and thanks to the opportunity that is bestowed to me to share my experience. My special thanks and appreciation for the learned audience for the kind attention. Thank you very much. I'll stop sharing, and the platform is now open for the questions. Thank you very much.
Thank you so much, sir, for educating us on CFA piles, its methodology, its trial, and suitability and application in Indian conditions. And moreover, you have educated us about the existing guidelines on CFA files, as well as upcoming guidelines that you have mentioned, sir. So we are going to take some question from our question and answer box. So question from Biman Pal. Is there any limiting depth of penetration for drilling?
We can get started with about a depth of about 10 to 25 meters. Okay, Indian condition, I'll always advise to go for about 20-meter pile and get a capacity close to about 75 to 150 tons. And to answer this question in a global perspective, the diameter of this pile can go even up to 1200 mm, and the length can go even up to 50 meters. But India will have to wait for a couple of years to see that 50-meter pile is executed. A good question.
Okay, sir. So next question from Ranjan Peter. Limitation of excavator mounted CFA pilings.
Yes, it has a limitation. Excavator mounted CFA pile will be suitable up to about 15 to 20 meters only. I'll say 15 meters. Capacity will also be less because the excavator may not have that crowd push, which we typically require to push the cage and probably to lift the flight. It requires a certain capacity. That will be a limitation of the excavator mounting. So I'll strongly limit the applications to 15 meters and to a pile capacity close to about 75 to 100 tons.
Okay, sir. So next question from engineer Kumar Mandal. Sir, can the required uniform cover to the pile reinforcement be ensured in case of CFA piles where the pile reinforcement is inserted after placing the pile concrete? Yes, sir.
That's a very important question. In fact, the cover blocks have to be in a roller form. They have to be circular. They cannot be square, just like any other piling. The cover blocks serve as a rollers. They have to be of sufficiently strong, and typically acrylic and synthetic blocks will be more suitable for CFA piles. But yes, a mortar-based cover blocks are also used. So sturdiness and strength of the cover block have to be ensured. Secondly, they have to be spaced at close spacing. I'll suggest you can place cover blocks at about 3 meter maximum spacing center to center. And at each level, you need to have about 3 to 4 cover blocks at a time. So this will ensure that your cage is lowered into the wet concrete and it rolls down into the wet concrete. A good question.
So another question from same engineer Kumar Mandal. Sir, can the quality of concrete in CFA be verified thoroughly by conducting the cross-hole sonic logging test other than low strain pile integrity test, like it does in case of board cast in situ pile?
The answer is very much and firm yes. Cross-hole sonic logging can be used for CFA pile also. A better test, as I told, is a thermal integrity profiling test also. All this ensure that the quality of concrete, quality of pile, integrity is addressed throughout the length of the pile. EIT, that is low strain integrity, has a limitation that as soon as it comes across the first defect, the race cannot travel beyond the first defect, which means all the length of the pile cannot be mapped for integrity by low strain integrity test. Whereas cross-hole and the thermal integrity, they can map the whole and complete length of the pile and give us integrity informations. It can give us the concrete property, the strength information. Thermal integrity profiling has better advantage that it gives the information of the pile beyond the cover, at the cover portion also. Whereas cross-hole integrity test doesn't give information beyond the reinforcement and at the cover portion. Thank you.
So next question from Suti Mohanty. We can see some displacement, residual stress even after unloading. Is this parameter considered during empirical calculation? Is there any code for it?
It's a very important question. Residual stresses, unfortunately, they don't find they are addressed in a conventional design. Residual stress, they are in fact responsible for what we see is the net displacement. Okay, there is a permanent displacement in the pile. It speaks volumes about the compressibility of the soil and the presence of the residual stress. This is still a burning issue. The residual stress will vary from the pile to pile, soil to soil, and the geometrics of the piles. So this is very much a matter of research, and I'll request all the academicians, researchers to go into the details of the impact of the residual stresses on the pile. There is a good reference on impact of residual stress by Fleming. Mr. Fleming has championed the causes of the residual stresses, and it will be important if Mr. Mahanti goes into that reference by Mr. Fleming. Thank you.
Okay. So we'll take the last question because we have paucity of time. This question from Subodhi Mukherjee. How CFA piles performed in low bearing capacity soil?
It performs very well. Subject to limitations, you cannot have a CFA pile in certain situations. Like if it is very soft clay, with the end about 1, 2, 3, the CFA pile may have its limitation. It cannot perform in a hard rock because the agar cannot be pushed into the hard rock. If you have identified that CFA pile is a feasible pile, then even in low bearing capacity of soil, the CFA pile performs well. I'll give you an example of our own trials. We had our pile length of 11 meters. Average SPT value in that 11 meter was about 15 to 16. For average SPT of 15 to 16, we got a ultimate capacity of more than 180 tons. This is a very, very high capacity. And if you compare with the board pile, the CFA pile is a winner. So even in low bearing capacity of soil, the CFA piles delivers a very high capacity and giving the advantage of up progress. Thank you.
Thank you very much, sir. So some questions are still unanswered, sir. So I will request participant to directly mail to Basarkar sir. Definitely you will get your answer. So and mail ID you will get from the our brochure. So thank you very much, sir. Thank you very much for your presentation. Over to Mr. Pranab.
Thank you very much. Thank you.
Thank you, Dr. Sunil Basarkar, sir, for the presentation and also putting together this whole workshop. And thank you, Dr. Shupya Paul, sir, for moderating the session and keeping it on time. Thank you so much. Now we move ahead to the last part of the workshop, acknowledgement and concluding remarks. So I request Dr. Supya Khatun, who is Associate Professor at Alia University, to deliver this acknowledgement.
Thank you, Mr. Pranab. Am I audible?
Yes, ma'am.
The Honorable Chairman of DFI, India, Mr. Mohan Ramanathan, the Honorable Chairman of IGS Kolkata Chapter, Professor Jagotjyoti Mondol, distinguished speakers of the webinar, passionate professionals, educators, members of DFI India and IGS Kolkata Chapter, and all the participants of the webinar. A very good day to all of you. I am very pleased to officiate the closing of this webinar by acknowledging and giving concluding remarks of the second online workshop on the CFA piles organized by DFA India and IGS Kolkata Chapter. This online conference is indeed a positive note to begin learning and understanding how CFA piling technology can be a game changer in Indian piling industry. It is fantastic to see that this conference has successfully attracted about 200 delegates, ranging from the presenters, experts, participants in the field of civil engineering across the globe. Now, with great pleasure, I take the opportunity to express my heartfelt gratitude to all people who helped in making this webinar a grand success. Congratulations to DFI India and IGS Kolkata Chapter for successfully organizing this online conference on such an interesting topic in the field of pile construction technology. I would like to thank Mr. Pranab Jha and Mr. Chiranjeev Sarkar for introducing us with the webinar. I express my sincere thanks to Dr. Abhijit Saha, Vice Chairman Kolkata Chapter of IGS, for introducing IGS Kolkata Chapter and its contribution in the vast field of geotechnical engineering. My thanks goes to Professor Jagotjyoti Mondol, Chairman, Kolkata Chapter of IGS, for introducing our speakers of the webinar. I would like to thank Mr. Mohan Ramanathan, Chair of DFI India, for giving the overview of DFI activities. My sincere and heartfelt gratitude to all the eminent speakers for enriching us with their invaluable speeches. I would like to thank all the moderators who coordinated this 4-hour session smoothly with their utmost efficiency. Now, let us take a glimpse of today's speech of the webinar. Our first speaker, Mr. Kumar Mitra, a senior geotechnical consultant, has delivered a speech on pile foundation design and construction practices with typical references to piling in West Bengal and eastern states of India. He has shared his vast knowledge on pile design and construction in India. He covered the types of piles and process of construction used in India with illustration of actual sites. He talked about large diameter piles with high end bearing capacity in alluvial deposits. He emphasized on proper design, quality control, and economy of safe and proper practices of pile foundation. Our second speaker of today's session, Dr. Martin Larisch, has presented on CFA piles construction technique and global practices. He has elaborately discussed the construction technique of CFA piles, mainly emphasized on background of CFA piling, its design, construction, quality control, and computer monitoring of CFA piles. He emphasized on special care in concrete mix for CFA piles, suitable ground condition for CFA piles, common design and construction risk related to CFA piles, and he shared the codal provision for risk assessment of CFA piles in USA. Our third speaker, Mr. Ian White and Mr. Prathmesh Wani, have delivered their presentation on ground improvement technique by controlled modulus columns. They have presented the use of controlled modulus columns as ground improvement technique and how its use, works in how its use is increasing globally. They covered the domain of application of its construction technique. Also, they also covered the cost impact, time impact, and vibration impact of CFA pile. And they mentioned that CFA pile is vibration-free technique. They have shown the execution of CMC and its instrumentation developed by Menard with some case studies. The fourth speaker of the session, Mr. Anirudhan, has delivered his speech on design approaches of CFA piles. Mr. Anirudhan has given a very insightful presentation in design of CFA piles. His presentation includes behavior, performance of CFA piles, and concluded that it is analogous to board cast in situ piles. He talked in details about design guidelines of CFA piles in India. He covered the detailed design calculation of ultimate bearing capacity of CFA piles in cohesive as well as in cohesionless soil for all types of loadings. The last speaker of today's webinar, Dr. Sunil S. Basarkar, the Vice Chair of DFI India, delivered a speech on CFA piles methodology, DFI trial, suitability, and application in India conditions. His presentation has focused on the methodology of CFA piles and its application in India. He has covered the need and benefits of alternative piles in India. His presentation shown the modification done in the instrumentation for CFA piles, also the future plan of instrumentation for execution of CFA piles. He discussed the key factors of quality control of CFA piles and updated monitoring systems used in construction of CFA piles by DFI team in India. He also shared with us that DFI is giving efforts to prepare the guidelines for CFA piles in India in line with IS 2911, and it will be coming soon. I once again thank all the speakers for their fruitful presentation. Thank you all for your participation and contribution to this insightful webinar. And lastly, I want to say that together we can build a brighter and more sustainable future for our nations and the world. So with the hope to meet all of you once again to share new ideas and knowledge on new area of engineering and technology, I may conclude the session. Thank you all once again.
Thank you so much, Dr. Supriya Khatun, for your concluding remarks. And before we sign off, we just want to remember the departed soul. So with a very heavy heart, we inform you about the sad demise of two stalwarts in the Indian Geotechnical fraternity who left us earlier this week, Dr. N.B. Nayak and Shri Anil Londhe. They were a great supporter of DFI of India. Dr. N.B. Nayak was also a recipient of DFI of India Lifetime Contribution Award in 2018. So we hope their soul rest in peace and the family finds strength to cope up with this irreplaceable loss. Thank you to all the attendees, the speakers, and the moderators for joining today's program, and see you all in the coming programs.